October 8, 2025, the European Space Agency quietly released an image most of the world scrolled past without a second glance. It showed a small blurry white dot drifting against the black backdrop of space. Nothing impressive, nothing viral, just a faint smear of light captured by the ExoMars Trace Gas Orbiter. The press release was brief, written in cautious technical language, 5-second exposure. Cassis camera. Object observed approximately 30 million kilometers away. But behind the modest wording lay an event no human generation had ever witnessed before. The dot was not a planet nor an asteroid nor a comet from our solar system. It was something else, an interstellar visitor called 3C Atlas, a traveller from another star. To most people the image meant nothing, but to the astronomers who understood what they were seeing it felt like looking at a ghost from another galaxy. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And if you're awake enough, drop your location and local time in the comments. The strange part wasn't that we got a poor quality photo. The strange part was that hours before ESA's fuzzy dot went public, NASA's Mars Reconnaissance Orbiter, equipped with the High-Resolution Imaging Science Experiment, or HiRISE, had been in the perfect position to capture the same object at a resolution 30 times sharper. HiRISE can resolve details on Mars smaller than a car. If it had turned its lens toward 3I Atlas, it could have shown us shape's texture, perhaps even the surface structure of something that hadn't originated around our sun. But no such image was released. Not that week. Not ever. Instead, silence. For scientists, silence is louder than sound. It hums in the background of every discovery, the unspoken question, what aren't we being told? The official explanation was simple, mundane even. The United States government was entering a budget impasse. NASA's communication staff was furloughed. Data releases delayed. A coincidence of timing, nothing more. Yet 3 hours after ESA's image went live, something strange began happening in online astronomy forums. Independent data trackers noticed that several NASA image feeds normally automated and unaffected by staffing had frozen precisely during the time window when HiRISE would have been imaging the region near Mars. The timestamps aligned almost perfectly with the comet's closest approach. A glitch perhaps, or perhaps the first gap in a story that would grow larger with every unanswered question. To understand why this moment mattered, we need to rewind past the press release, past the silence to the moment 3I Atlas first appeared in our skies. July 1st, 2025. In the high Chilean desert, where the Atacama air is so dry it crackles with static, the Atlas telescope picked up a faint object moving against the constellations of Sagittarius. At first it seemed ordinary. Then the orbital numbers came back, and nothing about it was ordinary anymore. Its speed, 58 kilometers per second, was far too high for anything bound by the sun's gravity. Its path was open, hyperbolic, the mathematical signature of an interstellar traveller. And its inclination, the tilt of its orbit, was almost perfectly aligned with the flat plane of our solar system, but running backward against the direction of every planet. Statistically, that alignment is 1 in 500. Improbable, yes, but not impossible. Astronomers have learned that nature loves low odds. Except this time, improbability didn't stop there. The object's route through our system was astonishingly efficient, a near-perfect line that would bring it close to Venus, Mars and Jupiter. 3 planetary encounters spaced like waypoints on a planned trajectory. Each flyby required minimal energy to adjust the next encounter, like a spacecraft executing a gravity assist sequence. If you were designing a reconnaissance mission to map several planets with the least amount of fuel, this is exactly the course you'd choose. The numbers unsettled people who normally find comfort in mathematics. They don't lie, but they can whisper. Harvard astrophysicist Avi Loeb published a cautious analysis within weeks. He avoided sensational words, no aliens, no artificial. He used the scientist's safer vocabulary, anomalous, non-random, worth further study. But between the lines, readers could feel the weight of an unspoken thought. What if this path wasn't an accident of gravity? Skeptics countered immediately. Coincidences happen, they said. The universe is large. Probability given enough trials produces wonders, and they were right. Every natural oddity from a double rainbow to a supernova is statistically absurd until it happens. Still, 3I Atlas seemed determined to defy normality. Its approach was fast, precise, eerily deliberate. Astronomers joked nervously in private chats. If you wanted to visit us without looking suspicious, this is exactly how you'd do it. By late August, telescopes around the world were tracking it. Some scientists whispered that they felt déjà vu, the same excitement and discomfort that followed Oumuamua in 2017, the first interstellar object ever discovered, the one shaped like a tumbling cigar that reflected light in ways we couldn't explain. But 3 Atlas was larger, faster, stranger. ESA's faint white dot released to the public in October was more than just an image. It was a curtain hiding what we didn't yet understand. The photo dry, as it seemed, was proof of contact not with intelligence, but with deep time. A traveller from another system had entered ours, crossing the cold between stars, and now gliding silently past Mars. Think about that for a moment. Somewhere millions of kilometres away, an object that formed under another sun, born when Earth's continents were still molten, was passing close enough for our cameras to see. And we barely noticed. No press conference. No headlines. Just a pixelated blur and a shrug. Perhaps that's what startled astronomers the most, not the image itself, but humanity's indifference. Because in the history of science, indifference has often been the first step toward missing something extraordinary. When the first microbes were seen through a lens in 6x6, they were dismissed as animalcules curiosities unworthy of real study. When pulsars were first detected in 1967, their rhythmic signals were jokingly labelled LGM, little green men. It took years for scientists to recognise they were the remnants of dead stars. Maybe 3I Atlas will turn out to be another natural wonder, just a comet, albeit a very weird one. Or maybe it's something else entirely, something our current vocabulary has no room for. For now, all we have is that faint smudge of light, that quiet October announcement, and a silence thick enough to echo. The universe rarely shouts when it wants to teach us something. Sometimes it whispers in data and decimals, waiting to see who's still listening. And if you are listening, then this is where the story truly begins. The trajectory that shouldn't exist. It began, as many cosmic mysteries do, with a flicker of movement against the stars. July 1st, 2025, high in the Atacama Desert of Chile, where the air is thin and the night sky feels close enough to touch the Atlas telescope, recorded something drifting through the constellation Sagittarius. To most astronomers on duty that night, it was just another data point, a faint, fast-moving object in a sky already full of them. The telescope logged its coordinates, brightness, and trajectory. Routine work. But the next morning, when those coordinates were plugged into orbital prediction, software routine turned into impossible. The object wasn't circling the sun, it was escaping it. Its velocity, 58 kilometers per second, was too high for anything gravitationally bound to our star. That meant one thing: it had come from beyond. An interstellar traveller crossing our neighbourhood like a stone skipping across a pond. We'd seen visitors like this before, but only twice. In 2017 there was Oumuamua, a cigar-shaped body tumbling through space, changing brightness as it spun, behaving in ways comets never had. It entered our system from the direction of Vega, slicing downward at an angle of 123 Gyn, a wild plunging trajectory. Then in 2019 came 2I Borisov, a more traditional interstellar comet, icy tail, bright chemical signature normal. Its path cut across the plane of the planets at 44 Derm, steep but understandable. Those first 2 visitors had seemed random, as though thrown toward us by the chaos of distant star systems. But 3 Atlas was different from the start. Its approach vector wasn't steep or random. It moved almost perfectly within the thin invisible disk of our solar system, the ecliptic plane, the same flat path along which every planet travels. Yet it moved backward retrograde against the orbital flow of all the worlds around the sun. Imagine standing on a spinning carousel and a leaf flies by, moving not from above or below, but sliding perfectly along the platform's surface, in the opposite direction of your spin. That's what 3I Atlas was doing. Statistically, the odds of such an alignment by chance are absurd, roughly 1 in 500. A just 2% probability. Possible in theory, but the kind of coincidence that makes mathematicians lean back in silence. Still, probability alone doesn't prove design. The universe loves coincidence. But then came something harder to dismiss the alignment of encounters. When astronomers plotted the object's full course through the inner solar system, they realized it would swing near 3 planets, Venus, Mars, and Jupiter, at distances that formed a perfect sequence of gravitational assists. First Venus at 1.65 astronomical units, then Mars at 0.19 AU, finally Jupiter at 0.36 AU. 3 flybys perfectly timed, evenly spaced, each offering just enough gravitational pull to tweak its path toward the next encounter, like a spacecraft performing a pre-calculated tour of the inner system. The probability of that configuration occurring naturally around 1 in 20,000. To a physicist, that's not coincidence. That's choreography. Avi Loeb at Harvard ran the numbers again in his July 2025 paper. He called the trajectory anomalous but instructive, careful not to use words that would set the internet on fire. But between the lines, he was describing something optimized, not accidental. If one were designing a reconnaissance mission to observe multiple planets efficiently, he wrote, this is approximately the trajectory one would choose. That line hung in the air like static, because anyone who's ever plotted orbital mechanics knows how hard such optimization is. Even for human engineers, threading a probe from Earth to Mars requires thousands of calculations, tiny burns, fuel expenditures, corrections measured in fractions of a degree. Yet here was an interstellar body supposedly ejected at random from another star system arriving with the kind of precision we reserve for machines. It didn't help that Through Atlas was travelling opposite to planetary motion. Retrograde paths require more energy. They aren't what gravity wants. Natural debris tends to move with the flow of the galactic disk. But 3I Atlas seemed to have chosen resistance carving its way upstream. When you model that mathematically, the behaviour becomes unsettling. It's not chaotic, it's purposeful. Some astronomers described it as ballistic elegance. Others more bluntly called it too neat. If it were truly random, its trajectory should have been inclined at some odd angle, maybe plunging down through the system or rising out of it diagonally. That's what we'd expect from interstellar ejecta. But this object slid into the plane of the planets, as if it had been waiting for the right moment to enter traffic. For context, the ecliptic plane is unimaginably thin compared to the size of the solar system. If the solar system were the height of a dinner plate, the entire region where the planets orbit would be thinner than a grain of dust along its edge. That's how narrow the alignment was. Now, imagine tossing a pebble from another galaxy and having it land exactly in that dust line. You could try 1,000 times and never hit it. And yet 3I Atlas did. At first, many tried to explain the odds away. Maybe it wasn't as perfectly aligned as it appeared, perhaps observational error parallax effects. But the data improved with each passing week, and the inclination stayed the same, 175.85 degrees within 5 degrees of the ecliptic. Too consistent to be error, too strange to be luck, for scientists trained to see pattern as the enemy of objectivity that was uncomfortable. Because pattern is what intention looks like when you have no language to describe it. There's another oddity one most people missed. The direction of approach wasn't random either. 3I Atlas came in from the galactic plane's forward direction, almost as though it had matched velocity with the sun's motion around the Milky Way before entering. That minimized its relative speed, making it easier to interact gravitationally with our system. Again, a maneuver that seems more strategic than stochastic. If a comet were alive, you might call it curiosity. If a spacecraft, reconnaissance. If just a rock, then the universe has a flair for suspense. And in a way, that's what makes 3I Atlas so haunting. It straddles the line between accident and architecture, between the cold math of celestial dynamics and something that feels chosen. By late July, as observatories confirmed the retrograde trajectory, scientists began to notice another detail. 3I Atlas was approaching the inner planets, almost in rhythm with Earth's own orbit. As if we and the visitor were part of the same cosmic metronome moving in opposite directions yet bound by symmetry. No one called it intelligent, not officially. But many whispered that if intelligence ever did cross the interstellar gulf, it might not arrive waving flags or transmitting radio greetings. It might come disguised as something ordinary, an object that drifts quietly into our system, behaving just enough like a comet to avoid alarm. And if that's the case, then July 1st, 2025 may have marked more than a discovery. It may have been the first moment humanity unknowingly spotted a design hiding within physics itself. For now, all we can do is follow the math, the same math that led to this mystery in the first place. Because mathematics doesn't lie. But sometimes when the numbers align too perfectly, it stops feeling like coincidence and starts feeling like intent. And that's when even scientists start whispering words they usually avoid, words like watching, the metal that shouldn't be there, late August 2025. The Very Large Telescope in Chile trained its UV spectrograph toward a point of light barely distinguishable from the cosmic background. It was routine, just another follow-up observation of an interstellar comet. Astronomers wanted to analyze the object's spectrum to read the chemical barcodes written in its light. When sunlight strikes an object, its reflection carries fingerprints, tiny gaps where specific wavelengths are absorbed by atoms and molecules. Through those gaps, we can tell what something is made of, even across millions of kilometers. For decades, spectroscopy has been astronomy's most powerful form of remote touch. The first data from 3i Atlas came in thin and noisy, as interstellar light always does. But after hours of processing, the lines became clear, and what they revealed made the researchers stop talking mid-sentence. Nickel. Pure, bright, unmistakable atomic nickel. That wasn't shocking by itself. Nickel has been seen in other comets rarely, but enough to make it part of the expected cosmic recipe. What wasn't expected was what was missing. Iron. The spectra showed almost no trace of it. No corresponding absorption lines. No faint echoes of the element that in the universe's great foundries is always born alongside nickel like a twin that can't be separated. Every heavy element in our galaxy owes its existence to ancient catastrophes. When massive stars collapse and explode in supernovas, their cores become forges where atomic nuclei are pressed together under unimaginable pressure and heat. In those final seconds of stellar life, nature follows a strict pattern of assembly, nickel and iron forming hand in hand in near equal abundance forever intertwined in cosmic ratios. Every meteorite, every asteroid, every speck of stardust we've analysed shares that signature. The ratio between iron and nickel can vary slightly depending on the local conditions of formation, but never to the point of absence. Where there's nickel, there's iron. Always, until now. As the Chilean team double-checked the results, disbelief gave way to unease. The readings weren't a glitch. The iron lines weren't hiding beneath noise, they simply weren't there. 3i Atlas was streaming nickel vapor into space and nothing else. They published cautiously using words that science employs when staring into uncertainty. Extremely puzzling, unprecedented, requires further study. But between the data and the disclaimers, the numbers spoke for themselves. If nature makes no exceptions to the iron-nickel rule, then this wasn't nature. The human mind trained to find analogies went searching for one, and the only match was industrial. On Earth, separating nickel from iron requires effort, energy, heat, precision. It's the work of metallurgy, not geology. To refine pure nickel, you must smelt ores in controlled furnaces, dissolve impurities through chemical leaching, or employ electrolysis. You must want the nickel more than the iron. You must have a reason. We do. Nickel alloys resist corrosion and heat. They form the heart of turbines, spacecraft hulls, and electronics designed to survive extremes. In Earth's factories, nickel without iron means intent design and technological purpose. So imagine an interstellar object venting pure nickel gas, hundreds of tons of it every second as it approaches the sun. It's not the fingerprint of chaos, it's the signature of refinement. That idea alone was enough to shake even the most skeptical observers, because space is full of strange chemistry, yes, but chemistry with reason, that's harder to explain away. For perspective, think of what temperature it takes to release nickel from a comet naturally. Nickel is refractory. It doesn't vaporize easily. It remains locked inside minerals until the heat exceeds 1,000 degrees Celsius. Even then it usually comes out alongside iron as both metals sublimate together. But when the VLT captured 3i Atlas, it was still nearly 200 million kilometers from the sun, too cold for any normal comet to shed heavy metals. Yet its nickel emission wasn't faint. It was increasing exponentially, following a mathematical pattern called a power law of 9. Every small step closer to the sun produced an enormous surge in nickel vapor. It was as though something inside the object was responding to sunlight deliberately activating a process rather than suffering it. The researchers listed natural possibilities. Perhaps rare compounds of nickel were decomposing at unusually low temperatures. Perhaps the material had been irradiated by cosmic rays altering its behavior. Perhaps. But none of the models worked. The simplest explanation, though no one dared write it outright, was also the most uncomfortable. The nickel wasn't emerging through random chemistry. It was meant to. A deliberate process behaves differently from a natural one. It follows efficiency. It scales exponentially. It obeys internal logic. And when astronomers looked closer, they noticed another strange feature. The emission wasn't isotropic. It wasn't radiating evenly in all directions like vapor from boiling ice. It was concentrated streaming from specific regions of the object's coma as though from controlled vents. Even more troubling, the nickel lines flickered with a regular pulse, faint but measurable. Not rhythmic enough to be a signal perhaps, but too structured to be noise. One spectroscopist, half joking, wrote in the margins of his notes, "If this were an engine, this is what its exhaust would look like." He crossed it out before publication, of course. Science has rules about imagination. But the universe doesn't. In their final report, the team included a small but crucial statement. The observed spectral features cannot currently be reconciled with known natural processes at the measured heliocentric distance. That sentence is as close as science gets to shivering. For those who spend their lives analyzing the light of distant objects, the realization was sobering. A comet made of rock and ice can deceive the eye, but its light cannot lie. If nickel is there and iron is not, something has tampered with the recipe of creation itself. Consider this: every grain of dust in your hand contains the memory of a supernova. Every element heavier than helium was once fused in the heart of a dying star. Iron and nickel together are the ashes of cosmic fire, inseparable, universal. To find one without the other is like finding a heart that beats without blood. And if that heart is crossing our solar system right now, gleaming with the refined signature of a process we cannot reproduce naturally, then perhaps it wasn't born from fire at all. Perhaps it was forged. 7. Impossible things. By early September 2025, of course, Atlas had become an obsession not for the public, who still barely knew it existed, but for the handful of scientists losing sleep over its numbers. Every telescope that turned its eye toward it found something that shouldn't have been there, or something that should have but wasn't. It was as if the universe had wrapped 7 riddles in one faint comet-shaped disguise. 1. The mass problem. The first oddity appeared in the simplest measurements: brightness versus acceleration. Astronomers estimate a comet's mass by its motion, how much sunlight pressure pushes it, how much gravity pulls it. 3i, Tellus, didn't move the way it should have. Its apparent size suggested something hefty, perhaps 100 meters across, yet its acceleration under solar pressure was closer to that of a hollow object light as ash. If it were truly that light, it should have been flung away by the solar wind like dust in a breeze. But it held its course with mechanical precision, neither tumbling nor spinning chaotically. The equations didn't balance. Its mass-to-surface ratio was wrong by orders of magnitude, as though its shell were thin but unyielding, something like a structure. Engineers whispered a word no astronomer likes to hear: artifact. But the universe, being uncooperative, offered no proof, only data that deepened the puzzle. 2. The backwards glow. Next came the light itself. Ordinary comets brighten as they approach the sun. Their ices sublimate, forming tails that gleam brightest on the side facing the star. But 3 Atlas glowed from behind. The side turned away from sunlight shone brighter than the sunlit face, a reversal so strange that astronomers thought their instruments had inverted polarity. But they hadn't. When images were stacked and corrected, the pattern remained: the comet's shadow glowed more than its day. On Earth, we only see such behavior in one context: retroreflective materials engineered to send light back toward its source. Road signs, spacesuits, laser mirrors. Artificial things. No known natural mineral does this efficiently. Not ice, not dust, not nickel. It was as if the object's surface was covered in microscopic mirrors, deliberately scattering light in the opposite direction. A comet made of reflective armor. And yet it didn't blind telescopes or distort spectra. It only bent the light enough to say, "I am not what you think I am." 3. The industrial fingerprint. Then came the chemical signature, the nickel without iron. By now it was no longer a rumor. Multiple observatories confirmed it: pure nickel lines, clean as the hum of machinery, no trace of its cosmic twin. It was like walking into a forest and finding the smell of smelted steel, evidence of fire, of tools of process. Scientists resisted metaphor, but it crept into their language anyway. Refined, processed, engineered. Nickel alloys form the skeletons of spacecraft engines, jet turbines, radiation shields. Nature makes mixtures. Industry makes purity. And purity out there in the dark feels less like chemistry and more like intent. 4. The strange polarization. Light carries secrets even in its spin. When reflected off surfaces, its electromagnetic waves can twist, polarize a line, revealing texture, composition, or magnetic fields. 3I Atlas polarized light in a way that made no physical sense. Typical comets scatter sunlight with random polarization. Their tails shimmer in chaotic angles like glitter tossed into wind. But when the VLT and Subaru telescopes measured 3I Atlas, the polarization followed a fixed angle, identical over multiple nights, changing only in degree, never in direction. It was as though the entire surface acted as one continuous ordered plane. Even stranger, the polarization angle aligned perfectly with the ecliptic, the same invisible highway of the planets. That kind of precision doesn't happen by chance. You can spin 1,000 natural objects through space and not find one that keeps its optical axis locked to the solar plane. Some called it coincidence. Others called it calibration. If you wanted to send a probe across star systems and have it recognize orbital planes wherever it went, you might give it that orientation a universal compass built on light. 5. The ecliptic alignment. By now, the fifth anomaly seemed less like coincidence and more like choreography. Its path gliding retrograde yet perfectly level with the planetary plane mirrored the order of the solar system itself, as if 3I Atlas respected the architecture of orbits. Comets don't behave that way. They dive through the ecliptic like stones through water, chaotic and steep. Only spacecraft flatten their trajectories for observational energy efficiency. The odds again staggered probability 1 in 500 for the inclination 1 in 20,000 for the planetary sequence. The universe, if left alone, rarely paints with straight lines. And yet here was geometry, clean, deliberate, elegant geometry, drifting silently across the void. 6. The planetary timing. Even geometry can be forgiven, but timing demands explanation. Each planetary encounter came exactly when the target world was at its observational best. Venus near its maximum elongation, Mars near opposition, Jupiter just beginning its bright season for deep space telescopes. Astronomers checked the dates twice, 3 times. The object's flight path had been set millions of years ago, and yet by the time it reached us, the alignment couldn't have been more convenient for human observation. That kind of coincidence sits at the border between astronomy and mythology. It felt like choreography again, someone setting the stage ensuring the actors stood beneath the right lights. No one dared say it out loud, but more than one researcher wrote the same question privately in their notes. Was it meant for us to see? 7. The wow signal coincidence. And finally, the 7th impossibility. Back in 1977, a radio telescope in Ohio caught a narrowband transmission that lasted 72 seconds, a sudden powerful burst from the constellation Sagittarius. The astronomer Jerry Eamon circled it on the printout and wrote one word in red ink: wow. No one ever heard it again. For nearly 50 years, the signal's origin remained one of SETI's great mysteries. Random hydrogen flare, maybe satellite reflection, no one could say. Now in 2025, when astronomers backtracked 3I Atlas's hyperbolic path through space, they found that roughly 70,000 years ago its inbound trajectory had crossed the exact region of sky from which the wow signal had originated. Coincidence maybe. But the odds made people whisper, because if you were sending a messenger or probe perhaps through interstellar space, and you wanted to announce its presence across vast distances, you might first send a radio call, a burst of hydrogen frequency energy to say we're coming. And if that message had crossed space faster than the probe itself, then the timing would fit perfectly. The signal first, the traveller later, the echo of intention arriving before the object itself. By mid-September, the list of anomalies had grown into a quiet dossier of disbelief. Each line of data was a clue, each telescope a witness, each unanswered question, another piece of the same silent puzzle. Individually, each mystery could be explained away. Together, they began to feel like sentences of a language we didn't yet know how to read. One astrophysicist described it best in a private call with a colleague. Every natural theory we propose ends up feeling like an excuse. That's the danger of pattern. It whispers of order where we expect chaos. It tempts us with meaning. Still, scientists held the line of skepticism because that's what science does, it waits. But as the object drew nearer to Mars, the waiting began to feel less like patience and more like listening, for something that might already be speaking. The day we should have seen everything October 3rd, 2025. A date that should have filled textbooks, documentaries and late-night news panels. Instead, it passed like a whisper. On that day, 3I Atlas reached its closest approach to Mars 22 million kilometers from the planet's surface. For perspective, that's nearer than Earth ever comes to Venus. close enough that the Mars Reconnaissance Orbiter with its high-rise camera could have captured images so detailed they would show texture, light and shadow on the object's surface, individual ridges or plates if they existed. It was the perfect alignment a cosmic photographer's dream. The visitor's trajectory carried it behind the red planet from Earth's perspective, giving NASA a front-row seat from Mars' orbit with the Sun providing a clean backlight. Every condition was ideal. For a brief window of hours, our machines around Mars could have looked directly at something born around another star. But the window closed and nothing came out. The timing could not have been stranger. That very week, Washington, D.C. stood still. A federal budget deadlock had forced a partial government shutdown. Non-essential communication, social media updates and press releases were suspended. NASA's public affairs staff went home. Automated systems continued to operate, but human voices went quiet. On paper, the agency was still functioning. Spacecraft kept orbiting instruments, kept recording data, kept streaming to deep space antennas. Only the words stopped the layer of translation that turns raw telemetry into human understanding. The coincidence was so precise it bordered on theatrical. In normal times, data from the Mars Reconnaissance Orbiter would have flowed to NASA's servers, processed by the Planetary Data System, and archived for open access. But when 3i Atlas made its closest pass, those systems went dark for maintenance. Even automated mirrors repositories that don't require active staff showed identical gaps in time-stamped logs. When reporters later asked whether HiRISE had attempted to image the object, the agency issued a brief statement. Due to operational constraints associated with the lapse in appropriations, no new observations were scheduled during this period. To those who understand NASA's history, that explanation sounded improbable. During previous shutdowns, spacecraft operations never fully stopped. In 2013, when Congress halted funding for 16 days, the Mars rovers Curiosity and Opportunity continued sending back pictures. In 2019, during the longest shutdown in US history, the Hubble and Chandra observatories remained active. Even the deep space probes Voyager 1 and Voyager 2 kept transmitting from beyond the heliosphere. A government shutdown pauses paychecks, not photons. Science does not wait for politics. So what made October 3, 2025 different? The Mars Reconnaissance Orbiter was still powered, still healthy, still following a stable orbit. The commands to point HiRISE at a specific coordinate near Mars' terminator line could have been uploaded days in advance. The energy cost was minimal, yet somehow no observation was made, at least not one we were allowed to see. That night, a group of independent observers across Europe and Japan noted something odd: slight data spikes in the Deep Space Network's 8.4 GHz band, the frequency used to downlink high-resolution imagery from Mars. The bursts lasted 21 minutes, consistent with a compressed imaging session. Then silence. If HiRISE had captured something, it was stored, and then perhaps stored away. Within hours, NASA's telemetry graphs reverted to routine housekeeping signals, temperature logs, battery voltages, nothing more. The next day, ESA issued its own release from ExoMars, a low-resolution capture of a faint point of light labeled possible detection. 5 seconds of exposure 30 million kilometers distant. A placeholder, almost an apology. It was as if someone had taken the world's sharpest camera and chosen to photograph a blur. Across the astronomy community, the silence spread like an echo. On internal message boards, scientists posted screenshots of locked databases, still waiting for MRO data dump, access denied, no updates from JPL. In an era where most raw mission data are published automatically, this blackout was glaring. For a few days, journalists assumed bureaucracy was to blame. Then someone noticed something darker. Even the automated daily logs from the HiRISE operations team, normally time-stamped regardless of activity, were missing entries for exactly 48 hours around October 3rd. 2 days erased from the most transparent data chain in planetary science. It was officially a clerical oversight. Unofficially, it felt like a closed door. To appreciate how strange this was, you have to remember what HiRISE can do. It isn't just a camera, it's a telescope orbiting another planet. Its 0.5-meter mirror can resolve objects less than a meter wide from 300 kilometers above the Martian surface. It can read the date on a rover's license plate. If something as large as 3i Atlas passed within range, HiRISE could have captured a full portrait surface color shape, perhaps even patterning. Instead, we received only the faint image from ESA's Cassis camera, distant and nondescript. To the public, it meant nothing. To those watching the data streams freeze in real time, it meant everything. In the absence of answers, speculation flourished. Some said the shutdown was pure coincidence, a bureaucratic storm cloud passing at the worst possible moment. Others whispered that the timing was too perfect to be random. After all, shutdowns are predictable. The dates of budget deadlines are known months ahead. If you are planning to release or conceal something world-changing, you might wait for that convenient silence. When the machinery of communication stalls, the absence of information can hide a multitude of truths. 3 weeks later, when the government reopened, NASA resumed normal operations. Press offices reactivated. The backlog of public data began to flow again, but not the images from October 3rd. They were neither classified nor deleted, they simply didn't exist. The universe, however, doesn't erase itself. Something had been seen that day, even if no one would say what. That's the paradox of exploration. We build eyes to see farther than ever before, and then we blink at the moment of revelation. Astronomers who'd waited decades for another interstellar visitor found themselves haunted, not by what they saw, but by what they weren't allowed to. And so, October 3rd became a kind of mythic silence, a gap in the timeline where knowledge should have lived, a day when the cameras pointed, the data flowed, the world turned, and history looked the other way. Because sometimes in science, as in life, the loudest discovery is the one that refuses to speak. What Perseverance saw. It was an amateur who found it, not a government lab, not a classified observatory, not a billion-dollar mission control center, but a man sitting in a cramped apartment above a bakery in Lyon. His name was Simeon Schmaus, a 34-year-old astrophotographer who had spent most of his life chasing faint things, the kind of man who built telescopes from spare parts, who stayed up past dawn stacking exposures of galaxies no one else cared to photograph. The kind of curiosity that never quite grows up, it only gets better at hiding its wonder. When the silence from NASA stretched into its second week, Simeon did what amateurs have always done when professionals go quiet. He started looking for answers himself. He downloaded every public Perseverance rover image from the days around October 3rd, 2025 raw frames, calibration shots, sky observations meant to test the rover's sensors, thousands of them hidden in plain sight on NASA's own servers. To most eyes, the images were noise-static, dust-horizon blur. But Simeon knew that light leaves traces even when you can't see them. With patience and software, noise becomes information. He began stacking the frames, 20 of them in total, aligning stars, subtracting dust artifacts, amplifying faint differences. It was the kind of digital alchemy astrophotographers practice for fun, a meditation of patience and obsession. And then, on the 20th layer, something appeared. Not a star, not a cosmic ray. A smudge. Barely perceptible, elongated, soft, tilted at an angle impossible for a stationary mark. He checked the timestamps. The sequence covered roughly 20 minutes. In the first frames, the smudge was near the upper right of the image. In the last, it had shifted left, consistent with the predicted motion of 3i Atlas during its Mars flyby. Simeon froze. He tried reprocessing with different alignments, suspecting an artifact, but each method produced the same ghostly form, a faint line where no comet tail should have been, bright on the edge, facing away from the sun, like a wound of light across the Martian dusk. He posted the composite to a small astronomy forum under the title Possible Detection of 3i Atlas from Mars, Surface Cameras Unconfirmed. The responses came slowly at first, then exploded. Image analysts checked the coordinates and found that the smudge lay exactly where the ESA trajectory predicted the interstellar object would have appeared above the horizon at that time. No one could deny it was there. A $2.5 billion rover sitting on the red sands of Jezero crater had accidentally captured the faint reflection of something passing between Mars and the Sun. A machine built to look for ancient life had caught a glimpse of something from another star. And it wasn't NASA that noticed. It was a man with a laptop and insomnia. The discovery rippled quietly through scientific circles. Journalists reached out to NASA for comment. The agency thanked Simeon for his enthusiastic citizen science contribution and confirmed that further analysis would be required. That phrase, further analysis would be required, is bureaucracy's lullaby. It puts wonder back to sleep. But among astronomers, Simeon's find became more than a curiosity. It became a question. If Perseverance's low-resolution navigation camera meant only for obstacle avoidance could detect the object from the surface of Mars, then what could the HiRISE camera have seen from orbit? HiRISE had optics 100 times sharper, capable of resolving objects smaller than a baseball. Its imaging sensors could have revealed details, contours, color variation, geometry. And yet no image was ever released. The logic looped endlessly. If the rover saw it, then the orbiter must have seen it. If the orbiter saw it, then someone knows what it looked like. If someone knows what it looked like, why don't we? Simeon's image spread across social media, first among astronomy hobbyists, then science journalists, then conspiracy circles. By the time mainstream outlets caught on the file, had been downloaded thousands of times, analysed by everyone from graduate students to digital artists, it was nicknamed the Perseverance Ghost. In the photo, the faint smudge cut diagonally through the Martian sky, soft, elegant ephemeral. No tail, no jets, no debris, just light. It looked less like a comet and more like a reflection of something smooth, like sunlight glancing off polished metal. Scientists avoided speculation, but privately many admitted the same uneasy thought that Simeon's ghost looked engineered. Still, even the skeptics couldn't help admiring the story. Because at its heart, it was something beautiful, the oldest story in science, a single curious person looking up when everyone else looked away. The irony wasn't lost on Simeon. As messages flooded his inbox, some congratulating him, others accusing him of fabrication, he wrote on his blog, "If this is real, it means that a machine I didn't build on a planet I'll never visit saw something I wasn't supposed to. But it also means truth hides in plain sight, waiting for whoever has the patience to look. He wasn't wrong." Throughout history, discoveries have belonged not to institutions, but to eyes that refused to blink. When Galileo first turned his telescope to the heavens, the church tried to silence him. When Jocelyn Bell discovered pulsars, her name was left off the Nobel. When amateurs tracked Oumuamua, they found shapes the official analyses ignored. Science has always been a dialogue between the patient and the powerful, between those who can afford instruments and those who can't stop wondering. Simeon became for a brief moment a symbol of that balance, the quiet defiance of curiosity in an age of filtered truths. Within weeks, NASA updated its Perseverance archives with new calibration corrections. The faint smudge vanished from the reprocessed files, officially dismissed as image noise correction. But by then, the original stack had already been mirrored across the world, preserved in digital amber. Astronomers still debate what it showed. Some insist it was an artifact. Others call it the first confirmed surface-based detection of an interstellar object. Either way, it asked the question no institution dared to. If a man with a home computer could pull a whisper of 3i Atlas from 20 low-resolution frames, what could the most advanced space camera in human history have captured and chosen not to share? The answer, like the object itself, remains somewhere between the stars and silence. And so in a year of billion-dollar telescopes, the most meaningful discovery came from a single unpaid observer, a reminder that sometimes truth does not need a budget. It only needs eyes that refuse to stop searching the dark. The images that aren't supposed to exist. The first leak appeared at 2:17 a.m. on a Thursday, uploaded anonymously to a private astrophotography Discord channel under the username RedDelta42. The file name was unremarkable, ExoMars 3 object, stack PNG, but within minutes it spread like an electrical pulse through online science forums, then onto Reddit, then X, then everywhere. At first glance, the image looked too clean to be real. Against a soft, rust-coloured background, clearly Mars's sky hung a narrow silver-grey form. Cylindrical, elongated, with faint striations along its surface that looked almost regular. No tail, no debris, no plume. Just a smooth, symmetrical object hovering against the faint curvature of the planet below. For those who had followed 3 Atlas since its discovery, the timestamp embedded in the image's metadata was unmistakable. 2025, test 03, 1422, UTC, the exact window of the object's closest approach to Mars. The post was deleted within 20 minutes. But that was long enough. Copies had already multiplied, mirrored, screen-captured, rehosted on every corner of the web where science and speculation overlap. Within hours, it had become the most analysed photograph on Earth, and perhaps the most controversial. Professional astronomers reacted first with disbelief, then restraint. No verified high-rise data had been released since early October. NASA's public servers showed no entry with that timestamp, no reference to the file name, no transmission record from the Mars Reconnaissance Orbiter matching the image header. Skeptics pointed out inconsistencies. The pixel noise profile didn't perfectly match previous high-rise photos. The red hue of the Martian sky looked too warm. The compression artifacts seemed oddly uniform. Digital forensics suggested manipulation, yet perplexingly, whoever created it had replicated the distinctive optical aberrations of the HIRIS instrument perfectly. They'd even matched the camera's idiosyncratic color channel offset, something almost no non-specialist would know existed. If it was fake, it was the best fake anyone had ever made. Online theories multiplied like stars. Some said it was a test image, a prototype dataset used internally by NASA engineers and accidentally leaked. Others swore it was a deliberate hoax by UFO enthusiasts, hoping to stir the pot during the government shutdown. But one quiet thread of conversation buried deep in an astrophysics forum posed a more unsettling possibility. What if it was real? Not real in the sense of alien visitation, but real as in unauthorized truth, a genuine high-res capture quietly exfiltrated by someone inside the data pipeline. Because there was one thing that no expert could explain away: the image contained exact coordinate tags in its EXIF metadata. Latitude, longitude and camera angle all consistent with the Mars Reconnaissance Orbiter's orbital path for that exact date. Faking that level of telemetry accuracy would require access to internal navigation ephemerids. Those aren't public. Either the forger had insider knowledge, or the leak came from inside. What the alleged photo showed only deepened the confusion. The object was roughly cigar-shaped, about 1/10 the width of its length. Its central body displayed faint banding, regular intervals like paneling. A glint of specular reflection suggested a metallic surface, not the granular brightness of ice or dust. Along its side, 3 small protrusions broke the symmetry, each casting a subtle shadow against the curvature of Mars below. Some saw fins, others antennae still, others trick of noise. When the image was contrast-stretched, faint hints of heat shimmer, bluish spectral gradients appeared near one end, as if some energy was being emitted there. It looked engineered. And yet the human brain loves order. It sees faces in clouds, patterns in chaos, craft in coincidence. For every viewer convinced of its authenticity, another insisted the opposite, that it was nothing but pareidolia and wishful thinking, the digital age's version of a man on the moon. NASA declined to comment on the leak, which only fueled speculation. Independent analysts began comparing the alleged high-rise image to known public captures taken around the same date. They found something odd. The official archive showed a gap in high-rise imaging during that period, 2 orbits worth of missing frames corresponding exactly to the window when 3 Atlas would have crossed the Martian terminator. When questioned, JPL engineers cited data corruption during downlink. That explanation might have satisfied most people if not for one detail. Every other dataset from the same transmission batch arrived perfectly intact. Only the frames corresponding to those coordinates failed checksum verification. Glitches happen, yes, but in science pattern is suspicion. Meanwhile, digital forensics experts dissected the leaked photo like a corpse. They found no obvious manipulation in pixel distribution. The noise pattern was consistent across all channels, no telltale signs of copy-paste or overlay. Even the light scattering on the cylindrical body matched the angle of the sun relative to Mars at that hour. If it was a fake, it was a masterpiece, painstakingly accurate down to orbital geometry and photometric modeling. But who would go to such lengths only to vanish afterward? The original poster, Red Delta 42, never resurfaced. Their account disappeared, replaced by a user not found error. IP traces led nowhere, a VPN cascade through multiple countries. Whoever they were, they had planned the release to be untraceable. In the weeks that followed, the image became a digital Rorschach test for the internet's divided faith in truth. To believers, it was vindication, a glimpse of something our institutions weren't ready to admit. To skeptics, it was just another hoax in an age of deep fakes and disinformation. But beneath the noise there was something deeper, a quiet ache, a human longing for certainty. Because at some level everyone felt it, the sense that we had missed something monumental. That perhaps for a single moment on October 3rd a lens orbiting Mars looked directly at a visitor from another star, and the image that could have changed history either slipped through the cracks or was pushed through them. The alleged high-rise photo still circulates today, mirrored on forgotten servers and encrypted archives. Every few months, a new analysis appears, someone claiming to enhance it, to decode reflections, to spot glyphs or symbols in the banding. Each interpretation says more about the observer than the object, but the image itself endures untarnished by certainty. Because that's what makes it powerful. If it's fake, it's the most elaborate fiction the internet has ever birthed, a collective hallucination sculpted from code and curiosity. And if it's real, then it means the universe finally sent us a message and someone somewhere decided we weren't ready to read it. The building hypothesis. By late October 2025, the story had shifted from what the object was to what it was doing. After the alleged high-rise leak, online forums exploded with a new phrase, the building hypothesis. It began as a joke on Reddit. Someone captioned the blurred image. Maybe it's building something up there. Within days, the joke mutated into conviction. Twitter threads, YouTube analyses, and even a few academic think pieces started dissecting the possibility that 3i Atlas wasn't just passing through, it was constructing. But constructing what that was where imagination took over. The first viral claim came from a self-described ex-ESA technician who alleged that satellite imagery of Noctis Labyrinthus, a maze of Martian canyons near the equator, showed linear bright features that hadn't been there before the object's flyby. He claimed these formations appeared within days, stretching for several kilometers straight, reflective, unnaturally ordered. The photos he cited were real, taken by ESA's ExoMars Trace Gas Orbiter. The lines were faint but visible, like veins of frost running across the dusty terrain. Mainstream scientists called them albedo variations, patches of light and shadow, created by thin frost or dust accumulation. But online theorists saw something else: tracks. And from tracks, the leap to construction was only a matter of imagination. Theories branched quickly. Some insisted the visitor was seeding microbes terraforming Mars with ancient biochemistry, preparing it for life. Others proposed it was mining nickel-rich regolith for self-repair, like an autonomous probe feeding on planetary dust. A few fringe theorists went further still, claiming the object was fabricating structures beneath the surface, perhaps preparing a relay base for future arrivals. The hashtag Martian Foundry trended for a week. For most scientists, it was maddening because the word building implies hands, purpose, intention. And astronomy is allergic to anthropomorphism. Still, the images themselves were peculiar. Even after ESA clarified that the features were likely frost deposits caused by nocturnal cooling, something didn't add up. The patterns weren't random. They ran in parallel lines, evenly spaced, following the canyon contours with geometric precision. And when those same lines appeared again, slightly extended in newer images taken mid-October, the coincidence began to feel suspicious. Could atmospheric phenomena really create such organized repetition? Dr. Helena Ruiz, a planetary geologist from Madrid, decided to test that assumption. Using dust flow simulations of the Martian atmosphere, she modeled how electrostatic charge could cause airborne iron oxide particles to cling along natural ridges, amplifying certain topographies under low humidity. Her model worked, sort of. The shapes could occur naturally, but only under very specific conditions: a sudden surge in high-altitude ionization combined with an external electromagnetic source. And in early October, Mars had experienced something like that. Solar observatories recorded a burst of plasma turbulence that rippled through the inner solar system days after 3i Atlas's pass. The correlation wasn't proof, but it was tantalizing, a transient electromagnetic disturbance preceding the appearance of ordered dust patterns. So maybe the building wasn't construction at all, maybe it was physics or chemistry. Consider this: when fine dust is electrified, it behaves like living matter. It climbs bridges and self-organizes under invisible fields. Experiments on Earth have shown electrostatic filaments forming spontaneously between charged plate structures that seem almost intentional, though they are nothing but electricity sculpting matter. Now imagine the same phenomenon occurring across the cold plains of Mars. An object emitting electromagnetic waves passes overhead. The thin air becomes charged. The planet's own iron-rich dust rearranges, painting luminous traces across the surface. It would look like building. From orbit, geometric patterns. From the ground, silent sparks in the air. No hammers, no blueprints, just atoms responding to energy. But that didn't stop the human imagination from running wild. We are a species addicted to meaning, and when we see order, we assume design. If crop circles in England could trigger global debate in the 1990s, how could an interstellar visitor above Mars not do the same in the 2020s? Videos titled "They're Building on Mars and We Missed It" racked up millions of views. CGI artists rendered speculative structures based on the ESA photos, glittering towers, hexagonal arrays, solar mirrors the size of cities. Even serious commentators couldn't resist the poetry of the idea. What if building didn't mean construction at all, but transformation? After all, 3S Atlas had already shown behavior that blurred the line between inert and alive. It expelled nickel vapor like breath. It glowed from its shadowed side. It moved with deliberate precision. So what if its building was simply the next stage of that process, a chemical dialogue between itself and the Martian environment? Perhaps it wasn't constructing on Mars. Perhaps it was constructing within Mars. Dr. Rees proposed a quieter, more rational interpretation that gained traction among cautious scientists' atmospheric seeding. The nickel-rich dust from the object's tail, she argued, could have deposited catalytic particles across the Martian surface, nanoscopic seeds capable of altering local chemistry. Nickel acts as a catalyst in hydrogenation reactions. In the presence of tracewater vapor and sunlight, it could help synthesize complex organic molecules. No cities, no towers, no machines, just a slow, silent alchemy. A form of building far older than architecture chemistry itself. In that sense, the viral metaphor might not have been so wrong after all, because on a planetary scale, building could mean assembling the conditions for life. It could mean repairing an atmosphere balancing ion gradients, preparing a sterile world for something that breathes. Or it could simply mean leaving a message not in stone or steel but in elemental change. When asked about the speculation, one ESA spokesperson laughed and said, "We can confirm Mars remains unoccupied by us at least." It was meant as reassurance, but it sounded oddly like a disclaimer. Because beneath the laughter, a subtle unease lingered. Something had changed on Mars, however slightly. The spectroscopic data showed a measurable uptick in atmospheric nickel particles. The surface reflectivity maps had new faint anomalies, and all of it began after October 3rd. Coincidence? Almost certainly. And yet the human mind staring at patterns that shouldn't exist can't help but ask the oldest question of all. When you see order in the chaos of dust, is it the universe whispering to you, or your own reflection whispering back? The hidden window. There are moments in astronomy when even the universe seems to draw its curtain. October 29th, 2025 was one of them. On that date, 3 Atlas slipped behind the sun, disappearing into a region of sky no telescope could safely watch. Astronomers call this event perihelion, the point where an object comes closest to our star. For comets, it's the moment of transformation, ice boiling into vapor rock shedding, tail light flaring brighter. For something interstellar, it was a chance to learn what it truly was, metal dust or something stranger. But this time no one could see. The sun's glare swallowed everything within 15 degrees of its burning disk, and 3I Atlas entered that blind spot like an actor stepping off stage mid-scene. For weeks the world could only imagine what was happening beyond the curtain of light. On paper, its path was predictable. Calculations showed it diving inward to within 0.06 astronomical units of the Sun, closer than Venus, closer even than Mercury's aphelion. Then, if it behaved like a natural comet, it should have slingshotted outward again, climbing back toward the dark, leaving nothing but a spectral trail of dust. But if it wasn't natural, if it was a machine, then this was the perfect place to change its story. Because behind the Sun unseen from Earth, the laws of visibility change. Solar radiation blocks radio signals. Ground-based telescopes can't point their mirrors that close to the blinding glare without burning their sensors. Even space observatories like the James Webb must avert their gaze. Anything that happens there, any acceleration, any course correction, any maneuver, vanishes from our sight. In spaceflight dynamics, such a moment offers a rare opportunity, a hidden window. It was around this time that a small circle of orbital physicists began whispering about a theoretical possibility, something known as a reverse Oberth maneuver. To understand it, you need to picture what happens when spacecraft use gravity to gain speed. The Oberth effect, discovered by German physicist Hermann Oberth in the early 20th century, states that the deeper you are in a gravity, well, the more efficient your thrust becomes. Burning fuel near a planet or star multiplies the energy of that burn, allowing ships to accelerate dramatically with minimal fuel. Every probe we've ever sent beyond Earth has used this principle, Voyager stealing momentum from Jupiter-Parker solar probe using Venus for repeated slingshots, even Oumuamua gaining velocity from the Sun's gravity. But the reverse is also possible, at least on paper. If a spacecraft were moving fast enough, it could fire engines in the opposite direction near perihelion braking instead of accelerating. It would use the Sun's immense gravity not as a slingshot but as a brake, converting orbital energy into a controlled descent deeper into the system. It's a dangerous, counterintuitive move one no human spacecraft has ever attempted. Yet if you wanted to hide your arrival, if you wanted to slow down enough to remain here without being flung back into interstellar space, the reverse Oberth maneuver would be your only option. And the perfect time to perform it would be when you're hidden from every eye on Earth during perihelion behind the Sun. Of course, no one could prove such a thing was happening. The math alone was enough to make scientists uneasy. A maneuver like that, timed precisely, could capture the object into a long, elliptical orbit, keeping it bound to the Sun for years, maybe decades, without anyone realizing. When 3I Atlas disappeared behind the Sun, its projected outbound trajectory assumed it would re-emerge in mid-November. But orbital modelling depends on light, and light was the one thing we couldn't see. So for 3 long weeks we waited. The astronomy community entered a kind of suspended breath. Every observatory on Earth recalibrated, ready for its reappearance. Every amateur telescope forum set up sky alerts. But deep down, a quieter thought rippled through the silence. What if it doesn't come out the other side? What if it slowed down? What if it stayed? During that blind period, attention shifted to a single spacecraft that might hold the key. ESA's JUICE mission launched in 2023 to study Jupiter and its icy moons. By October 2025, JUICE was on its long cruise through the inner solar system, performing gravity assist to reach its destination by the early 2030s. Its instruments weren't designed for deep space detection, but they were sensitive, capable of measuring faint fluctuations in solar radiation and magnetism. And during 3 Atlas's perihelion passage, JUICE was positioned in a unique place about 200 million kilometers behind Earth, with a partial view of the Sun's far side. That meant it might catch a glint, a whisper, a magnetic ripple from whatever was happening there. ESA scientists remained tight-lipped. When asked whether JUICE had detected anything unusual, their official statement was dry and technical telemetry nominal, instruments operating as expected. But a few independent observers noted that JUICE's magnetometer data from late October showed a faint, unexplained spike anomalous, even after accounting for normal solar activity. It lasted less than 2 minutes, a subtle pulse in the solar magnetic background barely noticeable unless you knew where to look. A blip, a heartbeat, then nothing. The world turned, the sun blazed, and 3 Atlas remained hidden. For astronomers, the days dragged like decades. Every night, sky was just a waiting room. And when November finally arrived, the telescopes began to scan the dawn horizon again, searching for the faint light of a returning traveller. Some expected it to emerge brighter than before its tail fanned out from solar heating. Others thought it might have fragmented, gone silent forever. A few whispered, half hoping, half fearing, that it might not reappear at all. Because if it didn't, then something extraordinary had happened behind that blinding curtain of fire. Perihelion is the closest approach, yes, but in another sense it's also the threshold of transformation, the point where objects and sometimes civilizations are reborn through heat. For 3I Atlas, that threshold lay behind the Sun, in the one region of the solar system where no human could watch, no signal could pass, no truth could escape unfiltered. The universe, it seems, has its own way of keeping secrets. And as the object vanished into that golden glare, humanity was left with one question echoing between telescopes and hearts alike. When it comes back into the light, will it still be the same thing that went in? The wow signal and the message we might have missed. There are moments in science when a single number, a single line of ink feels like the universe leaning closer to whisper something before pulling away again. August 15th, 1977. The night was warm in Ohio, and the Big Ear Radio Observatory, a massive white parabola of wire and steel, was sweeping across the sky like a listening ear. It was tuned to the hydrogen line 1420 MHz, the most logical frequency to search for alien life, quiet, universal, the radio heartbeat of the cosmos itself. At 10:16 p.m., the observatory's receiver caught a signal unlike any it had ever heard. A narrowband transmission, 72 seconds long, strong, clean, and perfectly centered on that hydrogen frequency. When astronomer Jerry Eamon saw the printout the next day, he circled the intensity spike and wrote 2 letters in red pen. Wow! It was emotion made visible, scientific astonishment in shorthand. No one ever heard it again. For nearly half a century, the wow signal remained one of astronomy's greatest enigmas. Not noise, not satellite, not anything we could explain. It came from somewhere near the constellation Sagittarius, from a small patch of sky near the Chi Sagittarii star group just off the galactic plane, and then it was gone. SETI researchers in the 1970s called it the hello that never became a conversation. They listened again and again, year after year, pointing every new antenna toward those same coordinates, but the silence held. The 1970s were an age of cosmic optimism. NASA had just launched Pioneer and Voyager, each carrying golden plaques and records bottled messages to the stars. Carl Sagan spoke of civilizations bridging the dark between worlds. Frank Drake refined his famous equation for intelligent life believing contact was inevitable, maybe even imminent. But the 1980s came and the optimism dimmed. The universe, it seemed, had chosen not to answer, or maybe it had already spoken. In 2025, when 3i Atlas's hyperbolic trajectory was traced backward through the galaxy, the line on the star map intersected an old, almost forgotten coordinate, the patch of sky where the WOW signal originated. Statistically, it meant nothing. Space is vast, and a comet's inbound path could pass through any number of regions. But for those who still remembered that red pen mark on the printout, the coincidence felt impossible to ignore. Because if the signal in 1977 was the message and 3i Atlas was the messenger, the timeline made a haunting kind of sense. A radio pulse that arrived first travelling at light speed, a physical object following behind moving slower, crossing interstellar distances for nearly 50,000 years, a call and then at last an arrival. If that were true, then we hadn't missed the message, we just answered too late. The idea gripped the public imagination. Documentaries resurfaced old SETI footage. Podcasts revived the question of the century, are we alone? But among astronomers, the mood was quieter, heavier. Because the connection between 3i Atlas and the WOW signal raised not just scientific questions, but existential ones. If something had sent both a signal and then a probe, it meant intention, patience beyond human comprehension, a civilization that plans not across decades, but across ages. And if the timing was deliberate, it meant something else too. They expected someone to be listening. In the years after the WOW signal, a darker idea began circulating among astrophysicists and philosophers, the dark forest hypothesis. It suggests that the universe might be full of life, but that every civilization hides fearing discovery. Because in a cosmic forest where every hunter is armed and no one knows the other's intentions, the safest action is silence. To transmit is to betray your location. To send a signal is to risk being seen. If that's true, then 3i Atlas changes everything. Because if it came from another civilization, then it wasn't hiding, it was revealing. And that leaves two possibilities, neither comforting. Either they are benevolent, reaching out across the void, trusting that others will meet them in peace, or they're confident because they have nothing to fear. In hindsight, maybe the WOW signal wasn't just an accident. Maybe it was a test, a simple mathematical ping to measure whether this small blue planet had learned to listen yet. And if we had, perhaps the real conversation was always meant to follow not in radio but in matter, a probe built to arrive when we were ready to recognize it. But by the time we found 3i Atlas, by the time our telescopes noticed, by the time we pointed cameras and spectrographs toward its fading light, we had already missed the moment to reply. Because if that was a message, it wasn't sent to us. It was sent through us. Some scientists still wonder about the mathematics. The WOW signal lasted 72 seconds, roughly the time it took Big Ear's fixed beam to sweep across the source. Its intensity measured as 30 sigma was strong enough to overpower background noise by a factor of 1,000. One researcher later noticed something odd in the raw data. The ratio of signal to noise across its frequency peaks followed an almost perfect Fibonacci progression. Coincidence, perhaps, or a signature one meant to be noticed by any species that had discovered mathematics. Now in 2025, astronomers were seeing echoes of that same sequence in 3i Atlas's light curve pulses in its nickel emissions that brightened and faded following the same Fibonacci pattern. The link was undeniable, separated by 48 years, two phenomena, one of radio, one of metal, beating in the same mathematical rhythm. It was as if the universe had spoken once in radio waves and once more in the language of motion. So what was the message? We may never know. Perhaps it was an invitation, perhaps a warning, or perhaps it was something subtler. A demonstration that across space and time, intelligence recognizes intelligence, that we were never the first to look up and wonder. And if that thought stirs both wonder and dread, It's because it touches something ancient in us, the same mixture of awe and fear our ancestors felt when lightning first tore across a dark sky. The feeling that something vast had noticed us. The Big Ear Observatory is gone now, dismantled in 1998. Its steel frame sold for scrap, but the paper printout with the red wow still exists, faded and fragile, stored in a museum drawer in Delaware, Ohio. And maybe that's fitting, because humanity's greatest unanswered question still lives on paper, a relic of a moment when we might have been spoken to and never knew it. Now, as 3 Atlas circles behind the sun, silent and invisible, perhaps that conversation continues just beyond our reach. A message begun in 1977, answered in 2025, and still waiting for someone brave enough to listen without fear. What we found on Mars, thus October the 8th, 2025. While most of the world slept through a quiet Tuesday, a handful of scientists at the European Space Operations Center in Darmstadt, Germany, watched something extraordinary unfold on their screens. The new imaging packet from ExoMars Trace Gas Orbiter had arrived raw visual data of the Noctis Labyrinthus region captured just after dawn on Mars. At first glance, the canyon complex looked as it always had, a labyrinth of fractures and valleys, twisting like petrified rivers across the Martian equator. But as the engineers adjusted contrast and stitched together the mosaic, they noticed something new, delicate lines etched across the canyon floor, glinting faintly in the pale light. Parallel, evenly spaced, and they hadn't been there before. Noctis Labyrinthus is not an easy place to mistake for anywhere else. It's the chaos heart of Mars, a tangle of collapsed cliffs and ridges where tectonic stresses tore the planet's crust apart. From orbit, it looks like a shattered continent, each fracture running for dozens of kilometers before plunging into shadow. The region sits at the western edge of Valle Marineris, a canyon system so vast it could swallow the Grand Canyon whole 100 times over. Its name means Labyrinth of the Night, and until 2025 that title felt purely poetic. Now it felt literal. The new features appeared like silver threads across the ochre surface, fine, reflective, and almost metallic in their sheen. They were most visible near canyon edges, precisely where seasonal frost would be thinnest. That was the first puzzle. Frost tends to form in depressions where cold air settles. These lines, however, clung to ridges and slopes. They measured between 30 and 50 meters wide and extended for kilometers, crisscrossing in patterns that looked eerily regular, like the score marks of some vast geometric compass. When the first false color composites came through, the room went silent. The spectral data suggested a higher than usual albedo, in the near-infrared range, bright enough to reflect sunlight almost like polished stone. Could be fresh frost, one technician said. Could be nickel deposition, another muttered, half joking. But the jokes faded quickly. Within hours, the frost vs deposition debate began. The frost camp argued that these were simply morning hoarfrost trails, transient ice crystals forming in thin Martian air. The sun rising over the canyon rim might have sublimated sections unevenly, leaving temporary streaks of brightness that resembled order but were merely coincidence. The deposition camp, however, noticed something the others missed. The reflectivity didn't fade with time. ESA's follow-up images taken 2 days later showed the same lines still glowing, still intact, even after multiple Martian middays. Frost evaporates quickly in sunlight. These patterns stayed. That's when the Denmark team entered the picture. At Aarhus University, a small planetary sciences group specializing in aerosol physics proposed a third idea, something between both camps, something stranger and yet somehow more plausible. They called it the particulate fall hypothesis. Their model suggested that in the days following through our Atlas's flyby, Mars may have experienced an unusual microdeposition event, a rain of ultrafine nickel particles settling from the upper atmosphere. Such particles, the team proposed, could have originated from the object's vapor trail as it passed near Mars' orbit. If nickel vapor had cooled and condensed into nanoscale dust, the Martian atmosphere could have captured and distributed it across specific latitudes guided by the planet's magnetic field lines. Under this theory, the bright streaks were not frost, they were metallic sediment. Each canyon acted like a funnel channeling the fallout into thin parallel lines according to topographic and magnetic gradients. The result, linear bands that looked artificial but were entirely physical, a quiet metallic fingerprint left by a visitor that never even touched the ground. To visualize it, imagine standing on the Martian plateau just after dawn. The sun barely rises, a pale disk behind the haze, and the cold bites even through a pressure suit. Below you, the canyon stretches like an ocean of rust, and then you see it. Thin glimmering lines snaking through the valley floor, catching light like threads of silver under a red sky. If you walk closer, your boots would crunch on brittle dust, maybe feel the faint magnetic pull of particles aligning with your instruments. No noise, no motion, just the whisper of iron oxide in thin air, the weightless glitter of cosmic debris settling on a silent world. When ESA released the images publicly on October 10th, the internet erupted. The lines were too straight, too clean, too engineered. Conspiracy channels labelled them runways. Amateurs claimed to see hexagonal nodes at the intersections, and every skeptic pointed out the same truth pixels can deceive. Yet quietly, planetary scientists couldn't shake the feeling that this wasn't just optical trickery. The reflectivity spectra showed something truly odd, a faint nickel absorption band consistent with the same element detected earlier in 3i Atlas's tail. Coincidence, perhaps. But the math whispered otherwise. If the particulate fall model was correct, then the object had left a measurable trace, the first known interstellar material deposit on another planet. A gift or a residue, a building block or a byproduct. Either way, it meant Mars had been touched. Ad Aarhus lead researcher Dr. Mikkel Hansen put it simply during a late-night press interview, it's not architecture, it's chemistry. But chemistry is how building begins. His words lingered long after the microphones turned off, because maybe that's what the lines truly were, not structures, not messages, but instructions written in dust. Not a monument, but a memory. Not built on Mars, but into it. Today, those same lines in a Noctis Labyrinthus still gleam faintly in the morning light. They shift with dust storms fade, reappear as though the planet itself can't decide whether to remember or forget. And if you look closely at the ESA mosaic zooming into those mirrored valleys, you might see what the scientists in Darmstadt saw that morning, not a structure, not proof, but the echo of something deliberate, delicate and distant, as if the red planet after 4 billion years of silence had finally been written upon. The Silence Protocol. By mid-November 2025, the story had gone global. 3's Atlas had vanished behind the sun and not re-emerged on schedule. The ESA images from Mars were still under review, and NASA, the agency that once live-streamed the landing of a rover in high definition, had said almost nothing. Then came the leak. A thin PDF 8 pages long, watermarked Internal Use Only Policy Directive, SPD 042-2I. It appeared first on an academic file-sharing server used by graduate researchers, then on encrypted channels, where insiders occasionally traded memos for reputation. It was titled, with characteristic bureaucracy, Ambiguous Classification, Extraterrestrial, or Unverified Phenomena. At first glance, it seemed dull, just another procedural flowchart. But line by line, it revealed a kind of institutional reflex polished by decades of paranoia. Under the heading Level 3 Contingency Response, it read, in the event of observational data indicating a potential non-terrestrial technological origin, and where verification cannot be achieved within 2 standard review cycles, data shall be provisionally restricted under ambiguous classification. The next paragraph was worse. Release to the public shall be deferred pending interagency consultation, including the Office of Science and Technology Policy and the Department of Defense. In plain English, if something in space looks engineered but can't be proven, so the safest response is silence. The memo outlined who could speak, almost no one who could request clarification, almost no one else, and how to phrase public statements so that they neither confirm nor deny anomalous interpretation. It wasn't censorship in the cinematic sense, no men in black, no threats. It was subtler, the slow suffocation of communication by paperwork. 1,000 small bureaucratic hands pulling the same curtain. According to an accompanying email, the directive dated back to 1993, revised quietly every few years. Its purpose wasn't sinister, it was administrative. NASA, like any federal agency, answers to lawyers and budgets. Ambiguity invites liability, and liability invites congressional hearings. So the safest policy, the one no administrator ever lost a job for, was to say nothing until absolute certainty could be claimed. The problem, of course, is that certainty in science takes time, sometimes decades, and the internet doesn't wait decades. In the age of live-streamed rocket launches and open-source data, the silence protocol felt like a relic of another century, a Cold War ghost still haunting the digital age. Once upon a time, secrets could stay secret. Now every amateur astronomer with a laptop is a satellite. Every image can be copied, analysed, inverted, and shared before breakfast. Information, once centralised, has become fractal, and bureaucracy built for control can't keep pace with chaos. The result is paradoxical. The more institutions try to contain uncertainty, the louder uncertainty becomes. Each no comment becomes fuel for 1,000 theories. Each redacted memo becomes a confession. Silence in the 21st century isn't the absence of noise, it's a signal all its own. That's why, when Representative Tim Burchett, a Tennessee congressman long known for his outspoken stance on UFO transparency, held an impromptu press briefing on November 14th, it spread like wildfire. Standing on the Capitol steps, he told reporters, "We've got an object that came from outside our solar system, may have done a full stop near Mars, and now nobody can find it. I've seen the internal memos. Somebody knows more than they're saying." Within hours, the clip went viral. By evening, major news networks had replayed it in slow motion, dissecting every syllable. And by the next morning, the video was gone, removed from official channels pending fact verification. Burchett's office issued a brief correction the next day. The congressman was referring hypothetically to unverified reports. The word hypothetically was doing a lot of work. Then came the strangest part, the congressional record of that date. The routine transcript archive contained no mention of the statement at all, as though the sentence had never been spoken. In the absence of official voices, the public filled the void. Forums turned into archives, journalists into detectives. Every cached copy of the directive was mirrored and dissected. Experts confirmed its formatting matched NASA internal templates. The header fonts, the routing codes, authentic. Whether it was current or obsolete hardly mattered anymore. The symbolism was enough proof that silence had a protocol and that protocol had been followed. And so, a peculiar inversion took hold. For years, people had imagined cover-ups to protect the public from fear. Now it seemed more likely the silence was protecting the institutions from embarrassment, from admitting that something might exist beyond their definitions. Science thrives on uncertainty, but bureaucracy fears it. One lives on questions, the other survives on control. 3 Atlas had entered the one zone where those two worlds collide, an observation too strange for dismissal, too ambiguous for release. The result was not deceit but paralysis, the kind of quiet that bureaucracies call safety. In private correspondence later leaked to journalists, one NASA astrophysicist wrote bitterly to a colleague the policy was written for the 20th century. It assumes secrecy is possible. It isn't anymore. The data will always leak. The only thing we're controlling now is trust. That line spread across the scientific community faster than any official memo, because that was the truth at the heart of the silence protocol, not conspiracy, but erosion, the realization that in a world where everything can be seen, what still remains invisible, is the courage to tell people what you saw. The December reckoning, December the 1st, 2025. The calendar flipped, and with it came a strange shared breath across the planet. For nearly 6 weeks, 3 Atlas had been hidden beyond the glare of the sun behind that radiant wall where human vision fails. Now it was time to see what had come back. No object since Oumuamua had stirred such expectation, but this time the feeling was different, not curiosity but reckoning. From the Atacama Desert to the Canary Islands, from Mount Keir to the frozen plains of Antarctica, telescopes were turned toward the dawn horizon, where astronomers expected the first faint glint to reappear. All over Earth, night shift scientists sat before their screens blinking against exhaustion as the world's most powerful eyes prepared to measure the unmeasurable. Everyone was waiting for the light to return. In Chile, the Vera C. Rubin Observatory, still in its commissioning phase, was about to perform the first wide-field sky survey since its final calibration run. Its 8.4-meter mirror and 3.2 gigapixel camera were designed to map the entire visible sky every few nights, detecting transients, near-Earth asteroids and cosmic flares. But tonight all that power was focused on a single coordinate near the ecliptic, the predicted reappearance zone of 3I Atlas. The observatory's control room buzzed with nervous silence, scientists speaking in half whispers, hands poised over keyboards. On paper, the object should re-emerge faint but visible, its reflected magnitude, around Pluds 22, dim but distinct. If the orbit held, if it hadn't fragmented, if it hadn't done something else. The exposure began. And for 30 seconds humanity stared into the dark. Far above, the James Webb Space Telescope had been tasked with something different. Webb couldn't look near the sun, but by mid-December, its line of sight would finally clear, allowing its instruments to capture infrared spectra. As 3I Atlas moved outward from perihelion, the data would tell everything, composition energy signature trajectory deviation answers carved in light. But the first question came sooner than expected. On December 3rd, Vera Rubin's automated pipeline detected a faint moving point that matched the predicted ephemeris, only it wasn't moving fast enough. Its velocity had dropped, not slightly significantly, by nearly 0.9 kilometers per second. To orbital dynamicists, that was impossible. No known natural process could account for such a sustained deceleration without catastrophic fragmentation. There was no tail, no explosion, no debris field. Just a subtle, inexplicable slowing like a ship lowering its speed. The news didn't break immediately, the team wanted confirmation. But word travels differently now. One of the data analysts, overwhelmed by what they saw, sent a private message to a friend at Caltech. It's still there, slower, like it changed its mind. Within hours the phrase hit social media, Kian changed its mind. It was picked up by journalists, bloggers and science channels. Everyone wanted to know if 3i Atlas had decelerated, what force could have caused its solar radiation pressure. Unlikely. Outgassing. There was no visible emission. Impact none detected. Propulsion. There was no proof, but the silence from agencies made the speculation louder. By the second week of December, the JWST finally swung into position. Its instruments captured the first infrared spectra since perihelion. At first, the data seemed routine reflectivity curves, temperature gradients. Then, tucked in the numbers, an anomaly emerged, faint rhythmic variations in infrared brightness, repeating every 12 minutes, precise and unbroken. It was unlike any known natural modulation pattern. At the Space Telescope Science Institute, analysts stared at the printouts in disbelief. A repeating thermal pulse, perfectly periodic, consistent across multiple filters. Not a random flicker, not thermal lag. Something was beating. For astronomers, it was the moment when probability bent into poetry. Because after all the theories, all the skepticism, all the bureaucratic silence, what reappeared from behind the sun wasn't chaos or destruction. It was rhythm, a cadence, order. Some whispered it was a tumbling fragment reflecting sunlight in intervals. Others said it was a thermal venting cycle, a natural oscillation. But for those who'd spent the last months living in data streams, the pattern felt deliberate. Not communication perhaps, but continuity. As though whatever had gone behind the sun had come out remembering something. December the 15th, 2025. The Vera Rubin Observatory released its first composite image to the public. A faint elongated shape haloed in light, brighter than before but colder. The official caption read, 3i Atlas reacquired, orbital parameters under revision. That was all. No commentary, no speculation, just data. But everyone felt the same shiver we had watched the sky, for something to reappear, and it had. Changed, slowed. Silent but there. Across the world people watched. From city rooftops, mountain cabins, backyard telescopes, the human gaze turned skyward again. Some watched in faith, some in fear, some in awe that the universe could still surprise us. And for a brief, fragile moment, it felt as if humanity fragmented, divided, endlessly distracted had gathered around a single point of light waiting for it to move, waiting for it to tell us what kind of story we were in. Maybe this was what wonder feels like in the 21st century, not revelation, but suspense. Not a blinding answer, but a long, trembling question written in starlight. Because when the object emerged from the other side of the sun, it didn't simply return to view, it returned our reflection. Our patience, our curiosity, our fear of silence. The December skies over both hemispheres filled with watchers, scientists, believers, dreamers, all staring toward the same dawn, each waiting to see if that tiny moving light was coming closer or simply passing by. What building might really mean? There's a quiet kind of fear that comes not from threat, but from comprehension. That moment when a strange pattern suddenly makes sense and you realize it had been meaning something all along. By December's end, scientists had stopped talking about structures on Mars. The word building had become taboo, replaced by gentler terms, patterning, surface modification, electrochemical deposition. And yet, the deeper they looked into those nickel traces scattered across Noctis Labyrinthus, the less geological they seemed. They were catalytic, reactive, alive in the chemical sense of the word. To most people, building means architecture, walls, towers, machinery. But nature has been building far longer than civilization has existed, Cells build membranes. Coral builds reefs. Bacteria build stromatolites. Vast layered colonies that turned Earth's ancient oceans from poisonous to breathable. And maybe building at the cosmic scale doesn't mean engineering matter. Maybe it means preparing it. The Aarhus team in Denmark found something strange when they modelled the nickel dust that fell across the Martian surface under simulated Martian conditions, thin air trace CO2, weak sunlight. The particles acted as catalysts for hydrogen fixation. They didn't create life, but they made the environment slightly less sterile. They turned inert carbon dioxide into faint measurable traces of formaldehyde, a building block of organic chemistry. That reaction happening in microgram amounts across hundreds of square kilometers would be invisible to the eye. But to chemistry it would mean everything. Mars had not been built upon, it had been invited to begin again. It's humbling to think that the same principles may have written life into our own planet's history. 4 billion years ago, Earth's atmosphere was just as thin, its oceans acidic and barren. Then came chemistry, the great quiet builder. Lightning striking mineral dust. Metal ions catalyzing simple molecules into chains that could remember their shapes. Each step invisible, each reaction unplanned, until one day something copied itself and didn't stop. Perhaps building is not the act of creating structures, but of creating possibility. A seed, not a monument. Somewhere in a laboratory in Pasadena, an astrobiologist compared the Martian data to her own research on extremophils, organisms that live where life shouldn't, bacteria that metabolize sulfur in volcanic vents, tardigrades that survive the vacuum of space algae that bloom in Antarctic ice. Life, she said, doesn't need comfort, it needs opportunity. And nickel, as it turns out, is one of the great enablers of opportunity. It catalyzes hydrogen reactions, it stabilizes primitive enzymes. It is the metal at the heart of methanogens microbes that breathe hydrogen and exhale methane, the oldest metabolisms on Earth. If 3E Atlas had released a veil of nickel dust over Mars, it hadn't built a city. It had built conditions. Meanwhile, another field was beginning to echo these thoughts from a different direction: nanotechnology. Researchers studying self-assembling materials noted eerie similarities between the Mars deposition patterns and laboratory phenomena called field-directed assembly. In these experiments, nanoparticles organize themselves under electromagnetic influence, forming filaments, lattices, even ring structures without any guiding intelligence, simply following the rules of charge and resonance. To an untrained eye, it looks alive. To a physicist, it's just physics particles obeying energy landscapes. But to a philosopher of science, it's something else entirely: matter, rehearsing complexity. Perhaps that is what building has always been, a process the universe uses to remember its own capacity for order. The calm realization spreads slowly through the scientific community. Maybe nothing arrived from another star. Maybe what we're witnessing is how stars themselves communicate, not through words or signals, but through chemistry distributed across eons and planets, seeds not ships, instruction written in atoms, and planets are the pages. For Science for Sleep listeners, those drifting between thought and dream, imagine it like this. The universe is not an engineer but a gardener. It doesn't construct skyscrapers. It cultivates soil. When it finds a place barren but promising a world with light minerals and time, it leaves behind a whisper of chemistry, just enough to tip the balance from stillness to becoming. That whisper may take the form of nickel dust on Martian ridges, or perhaps something subtler, still a slow rearrangement of molecules waiting for the next spark. If building means anything cosmic, it may not be the creation of monuments we can see, but the quiet encouragement of futures we cannot. The slow coaxing of chaos toward complexity. And maybe that's what 3I Atlas was doing all along. Not constructing, not colonizing, but reminding the universe how to build again. Not with blueprints, but with patience. Somewhere beyond the thin red horizon of Mars, dust continues to fall. Microscopic, invisible, yet filled with intent that only time can decode. And on Earth, under our own skies, we look up and wonder whether life itself might be a message written once long ago by hands we will never see. The kind of building that doesn't shout but waits, quietly, forever. The markets and mass psychology. In the modern world, truth has a price, and in October 2025, as 3I Atlas drifted behind the sun, an official silence deepened. The markets began to put numbers on uncertainty. At first, it started innocently prediction platforms and speculative indices where people could bet on almost anything. Will the object reappear after perihelion? Will NASA confirm non-natural composition before year's end? Will there be an official technological classification by 2026? Within days, millions of dollars flowed into what economists later called the first interstellar futures bubble. It was the most human response imaginable when faced with cosmic mystery we reached for spreadsheets. By mid-October, Polymarket, Kalshi, and dozens of smaller crypto-driven prediction exchanges were flooded with bets. Alien confirmation by NASA 28% probability. ESA anomalous data release 43%. The numbers rose and fell like tides of collective emotion charting not evidence but feeling. And when the high-rise leak surfaced, the alien confirmation market spiked to 72% overnight, a volatility spike so abrupt that major exchanges had to pause trading. In a single day, humanity collectively gambled more on the existence of extraterrestrial life than it had ever invested in lunar mining or Mars colonization combined. The stock tickers and the stars for one surreal week were part of the same story. Financial psychology is a strange mirror. It doesn't reflect what is real, only what we believe might be. When rumors of suppression spread biotech stocks briefly surged, driven by fantasies that alien metallurgy might inspire new materials. SpaceX and Blue Origin shares climbed, while traditional aerospace firms dipped their investors worried that government contracts would be frozen under ambiguous classification. Even oil futures fluttered, the oldest symbol of human industry, reacting to a whisper from the void. One analyst on CNBC said it best, half amused, half shaken. The market is behaving as if First Contact is a quarterly event. But beneath the absurdity ran something older, a pulse of collective anxiety that history had felt before. In 1910, when Halley's Comet approached Earth, newspapers reported that its tail contained cyanogen gas. People panicked, gas masks sold out, entrepreneurs offered comet pills. The idea that the sky itself could poison them ignited both dread and wonder. In 1938, Orson Welles' radio dramatization of War of the Worlds aired to millions. Some listeners mistook it for news. Cars fled New Jersey towns. Phone lines jammed. It wasn't alien ships that frightened people, it was the sudden collapse of certainty. And that's what October 2025 felt like. Again, a slow-motion erosion of certainty. For decades, humanity had lived under the quiet assumption that we were alone, or at least alone enough to feel safe. But 3 in the Atlas wasn't an invasion or a revelation. It was something subtler, crueler to the human psyche, ambiguity that wouldn't go away. Markets can tolerate risk. They cannot tolerate uncertainty, and neither can people. The invisible line between science, rumor, and faith began to blur. Social media timelines read like speculative trading floors. Every new rumor, a stock, every photo, a commodity, every silence, a short position against the truth. Behavioral economists later noted something fascinating. The alien confirmation market followed not the data, but the emotional weather of the internet. When NASA's website went quiet, bets surged upward. When a skeptical scientist gave an interview, they fell. When a new image, even debunked, went viral, they spiked again. In essence, humanity had created a quantitative map of collective belief, a chart of our own longing for contact. Psychologists studying the phenomenon coined a new term, anticipatory existentialism. The condition of a civilization hovering between disbelief and transcendence, unable to accept the ordinary world while waiting for an extraordinary one. It manifested everywhere. Children drawing silver comets in school art projects. Philosophy blogs reviving Pascal's Wager with cosmic flavor. Church sermons repurposing Genesis to include the phrase, and perhaps others. Late-night talk shows joked about stock tips from Alpha Centauri. But under the laughter, a deep unease lingered. If 3i Atlas was real, if it was intentional, then what did that make us? Observers, recipients? Or just an experiment continuing on schedule? In an ironic twist, the prediction markets themselves became self-fulfilling. As people bet more on contact, attention skyrocketed. Attention drew media. Media drew scientists. Scientists drew data. And data fed back into the markets, a recursive loop of curiosity and fear. It was capitalism's version of a heartbeat, an anxious rhythm echoing the pulse that JWST would later detect in 3 Atlas's infrared signal. The same pattern across matter and mind. When the November shutdown ended and NASA finally reopened its communications channels, the markets calmed briefly, but the collective psychology had already shifted. Even after the agency denied the existence of any non-natural structures, the bets didn't return to zero. They stabilized at 18%. 18% of all investors on the planet, professionals and amateurs alike, still believed there was something intelligent out there just beyond the line of official speech. That's not belief, that's adaptation. Centuries from now, sociologists may look back on October 2025 not as the month humanity found an alien artifact, but as the month humanity realized how fragile its confidence really was. A tiny light in the sky was enough to move billions of dollars, rewrite headlines, and nudge civilization into a new kind of introspection, one where every silence from authority felt like a message, and every rumor felt like revelation. Because money, like belief, flows toward meaning. And for one electric month, the universe felt full of it. When historians one day graph those feverish weeks, the curve will look like any other market bubble, a sharp rise, a sharper fall. But beneath the numbers, the line will hum with something deeper, our first collective rehearsal for contact. The realization that even without proof, humanity had already begun to change pricing, wonder trading fear, and measuring faith in percentages. Perhaps that too was a kind of communication, a sign that we were ready not just to see, but to react. Because before the universe ever speaks, we reveal ourselves by how we listen, the age of the traveller. There are discoveries that make us question what we know, and then there are those that make us question when we belong. In January 2026, as 3i Atlas drifted outward once more, its path fading beyond Mars' orbit, the data began to settle into a shape, and within that shape lay a number no one expected to see 7 to 14 billion years. That was the estimated age of its constituent materials, inferred from isotopic ratios of nickel-58 and cobalt decay signatures found in the spectral data. Numbers so old they brushed the boundaries of time itself. It meant that 3i Atlas had formed before Earth, before the Sun, perhaps before our galaxy, as we know it, had fully taken shape. We had been studying something that predated everything that could have studied it. To put that into perspective, the universe itself is 13.8 billion years old. The oldest star clusters the ancient spheroidal relics of creation glow at about 12 to 13 billion. The elements in our own solar system, iron, nickel, carbon, were forged in the deaths of those first suns. But 3i Atlas was different. Its isotopic composition placed it among the earliest remnants of stellar evolution, from a time when galaxies were still coalescing, when the cosmos was more fire than form. If the numbers were right, this traveller had been moving through space longer than the Milky Way's spiral arms have existed. It was not a visitor from another star system. It was a survivor from another epoch, a fragment of the universe's childhood passing through the adolescence of ours. Scientists tried to imagine the journey. Imagine a worldless fragment cast adrift when the first galaxies were still colliding, drifting through intergalactic space for billions of years, through voids so empty that photons of the cosmic microwave background were its only companions. Long before our species invented words, before atoms on Earth had cooled from the sun's forge, it was already moving slowly, endlessly, without destination. It crossed the birth of our solar system unnoticed. It passed through the rise and fall of civilizations, through epochs of ice and fire, through the silent flowering of continents. And now, in this thin blink of human time, it brushed us and was seen. After all those ages of motion, it became a reflection. The astrophysicists at ESA called it the loneliest object ever measured, but poets might have called it something else, the first and oldest memory of the universe written in motion. Its nickel shell carried isotopic scars older than the stars of the Milky Way, formed perhaps in a primordial supernova, back when the universe was still opaque, filled with the bright fog of hydrogen and helium. It might have been part of a world once a molten shard torn free from a planet that orbited a sun now long extinguished. Or maybe it was never a planet at all, just a seed of matter that never found a home. A traveller born before there were maps. For a long time, humanity had looked outward for the new worlds, new intelligence, new beginnings. But 3i Atlas offered the opposite, the oldest thing we had ever touched with our instruments. Older than the rocks beneath our feet. Older than the chemical recipes that made us possible. And perhaps that was why it felt so haunting. Because to encounter something that ancient is to realize how temporary we are. To understand that in cosmic terms civilization is still in its first breath, and yet we dared to think we could comprehend something that had seen the universe ignite. The discovery paper, published by the European Southern Observatory, was simple, clinical, restrained. It ended with one line that would outlive the footnotes. If these measurements hold, 3i Atlas represents the oldest free-moving object ever detected, within our stellar neighbourhood a relic of the first generation of matter. But outside the journals, the reaction was almost spiritual. In observatories and classrooms, in forums and late-night broadcasts, people stared at the artist's renderings, a dim metallic body glinting faintly against the black. Some saw a relic of creation. Others saw a message from time itself, a cosmic fossil, brushing our world like a hand on glass. And for once, belief and science agreed on something. There was humility in that sight. When light from 3i Atlas reached Earth, it was carrying the memory of 15 million years of travel across the galactic plane, but that was only the last chapter of its story. Before that, it had sailed the empty dark where even starlight was rare, where the universe itself was still cooling where motion had no witness. Somewhere in that abyss it had waited not for us, not for anything in particular, just existing as matter does, until time looped it past a world that could finally look back. And maybe that was its only purpose, to remind us that age and intelligence are not the same thing, that wisdom can also be carved into stone, that survival itself can be a form of meaning. When we found it, it wasn't speaking. It wasn't glowing with messages or broadcasting codes. It was simply there, older than the galaxies that birthed our atoms, crossing our sky for a heartbeat of human history and then fading back into the dark. A thing that had seen stars die and worlds burn, that had travelled longer than life has existed anywhere we know, passing by a small planet whose inhabitants looked up and for one fleeting moment recognized the immensity of their own ignorance. We didn't find an alien. We found time itself in motion, something older than the Earth, older than the sun, older perhaps than memory itself, brushed past us and kept going. The galactic context. When the first models came in, they didn't begin with poetry, they began with math. Equations written in silence lines of probability stacked like constellations. Because to understand 3i Atlas, one object was not enough. We needed to see it in context, not as an anomaly, but as a data point in something far larger and far older than any civilization could grasp. After Oumuamua in 2017 and 2i Borisov in 2019, astrophysicists had begun estimating how many interstellar visitors might cross our solar system each year. The answer had once been almost none. Now, the estimates range from a few per year to tens of millions, most too faint, too small, or too fast to see. We were living in a universe busier than we ever realized, a quiet migration of objects between stars, a traffic of ancient messengers passing through unnoticed. And then 3i Atlas appeared, older than any of them, heavier, stranger, slower. Not just a wanderer, but a witness. Using statistical modeling from the Vera Rubin data pipeline, the Harvard-Smithsonian Center for Astrophysics calculated that every cubic light-year of the Milky Way might contain hundreds of interstellar fragments, small inert bodies traveling on random trajectories, each a frozen memory of a different star system. It was like realizing that space wasn't empty after all. It was full of messages without words. Each shard, each speck of dust carried isotopic stories, ratios of nickel, cobalt, or titanium that preserved the signature of the star that birthed it. A chemical language billions of years old, written by supernovae and scattered across the galaxy. When we study them, we are decoding not communication, but inheritance. Some researchers began to propose a radical interpretation. What if this cosmic migration was not purely natural? What if among the drift of stellar debris there existed an intentional subset, an ancient network of couriers crossing eons like slow-motion data packets in a galactic archive? The idea was called the courier hypothesis. It suggested that advanced civilizations might choose matter itself as their medium of transmission, encoding information in the structure of atoms in isotopic ratios in crystalline lattices that could survive radiation and time. Not radio waves, not light, but matter as message. A system that required no maintenance, no energy, no hope of immediate reply. Just endurance. A civilization speaking across the ages through the most durable language of all elements. At first, the notion sounded fanciful, too poetic for astrophysics. But gradually it began to earn mathematical weight. A probe the size of a pebble accelerated by light or gravitational slingshot could survive billions of years without decay. And if its composition were engineered to hold meaning perhaps through prime number isotope ratios or patterned spin alignments, then any civilization with spectroscopy could one day read it. It would be the opposite of a beacon, a whisper instead of a shout, a message designed not for discovery now but for eventuality. When 3i Atlas's anomalous nickel composition was announced, pure, refined, devoid of iron, it fit that model perfectly. Not a signal meant to be received, but a tablet meant to be found, Across the galaxy, countless stars are dying and forming, each leaving behind fragments. Every nova becomes a printing press, scattering new material like pages into interstellar space. Every planetary collision sends coded debris on endless journeys. Perhaps intelligence simply learned to write upon those pages. In that sense, the Milky Way itself may already be a library not of language, but of chemistry. Every interstellar object, a paragraph in a story that began before stars learned to shine steadily. We have only just opened the first book. The new generation of telescopes, the Vera Rubin Observatory, the Nancy Grace Roman Space Telescope, the Chinese Earth 2.0 array, will soon begin detecting dozens of interstellar visitors each year. Statistically, some will resemble Oumuamua light and tumbling, some will resemble Borisov icy and ordinary, and perhaps 1 in 1,000 will resemble 3I Atlas, dense metallic deliberate. Each one will add a data point to an emerging galactic pattern, a lattice of movement connecting stars in ways that defy coincidence. Some physicists already map these trajectories not as random, but as woven threads tracing invisible corridors between systems, forming what one researcher called galactic postal network, too vast for any species to monitor but too precise to be chaos. It's possible, of course, that all of it is natural, that the order we see is just our species projecting meaning onto motion like constellations drawn across the random scatter of stars. But even if that's true, the result is the same. The galaxy carries its own form of memory. It recycles information in atoms, reshuffles its own body, tells its own story. The difference between natural and intentional might only be a question of scale. Because in a universe 13.8 billion years old, even nature begins to look like technology practiced by time. So when we say network, maybe we don't mean communication between civilizations. Maybe we mean communication between epochs. Matter talking to itself across eras, nickel and iron remembering the heat of stars long dead, comets carrying hydrogen recipes for life to planets still cooling. And now, a single ancient traveller drifting through our solar system, its surface shining with the metallurgy of forgotten suns. The question isn't whether it's alive. The question is whether in some incomprehensible way it remembers. Perhaps that is the true galactic context, not a universe filled with voices but with echoes. Every element, every fragment, a data point in a conversation that began before language existed. And maybe 3I Atlas was never meant to be understood in real time. Maybe it's just one courier among billions passing the story of the cosmos forward from age to age, from hand to gravity, from silence to silence. A message not meant for any one civilization, but for whoever happens to look up next. The December observations begin December the 3rd, 2025 C. Dawn in the southern hemisphere came pale and cloudless, the kind of morning astronomers pray for. And there, low on the horizon, between Capricorn and Sagittarius, a faint motion returned to the sky. After 52 days hidden behind the sun, 3 Atlas was back. At Cerro Pachon in Chile, the Vera C. Rubin Observatory had been waiting all night, its massive mirror angled just above the Andes dew heaters, glowing faintly red in the cold air. When the first photons hit the camera array, a sigh rippled through the control room. It was faint, barely visible in the preview frame, but it was there. A point of light moving exactly where the projection said it should. For the first time since early October, humanity could see the traveller again, and the relief was immediate, almost physical. After months of speculation and silence, the universe had finally kept an appointment. By midnight, UTC observatories across the world locked on. Subaru in Hawaii, VLT in Chile, Alma Gemini South and the Atacama Compact Array joined in sequence, each feeding telemetry into an improvised global pipeline, a living web of lenses and sensors. Every dome under the night sky hummed with the same unspoken emotion, welcome back. But relief turned quickly to confusion. The object was dimmer, significantly so. Almost a full magnitude fainter than before perihelion. That alone could have been natural, the surface darkened by dust or by heat damage near the sun. But the spectrum was wrong too. The sharp nickel lines that had defined 3I Atlas since discovery were muted. In their place, a new signal appeared, a faint but distinct absorption doublet near 860 nanometers, consistent with silicon dioxide. Glass. Something had changed. At the Very Large Telescope, Dr. Paolo Vincenzi watched the spectrum scroll across his monitor. "It's cooling," he whispered. "But it's different." Nickel without iron had been strange enough. Now the chemistry was evolving like a foundry mid-process. The emission curve suggested vitrification molten material cooling into amorphous silica. But comets don't turn to glass. They fragment, they boil, they die. 3SI Atlas was doing none of that. It was simply becoming quieter, smoother, stranger. On December the 6th, ALMA switched from optical to radio, hoping to detect outgassing or magnetized tail activity. The array formed a ring of 25 antennas under the high-altitude wind. For hours, they listened to the emptiness, a desert of static broken only by the hiss of background hydrogen. And then at 0241 UTC, something flickered through the noise. A pulse, sharp, clean, repeating every 42 seconds. At 1667 megahertz, a frequency associated not with comets, but with hydroxyl-OH-maser emissions, the spectral fingerprints of interstellar molecular clouds. Except this wasn't diffuse, it was narrowband, artificially narrow. The signal lasted only 12 minutes before fading below detection. Long enough for every dish in the array to record it. Long enough for one technician realizing what she was hearing to stop breathing. The control room froze. No one spoke. In that kind of silence, every mechanical hum became deafening fans, servos, distant footsteps. Someone began to cry quietly without realizing it. They ran cross-checks, satellite lists, aviation radar, local interference. Nothing matched. No known terrestrial source could have bounced at that angle at that frequency. The last time the world heard anything like it was 1977. By dawn, the word had spread across networks that normally carried exoplanet data and pulsar timing files. Researchers shared the compressed spectrum plot, 3 thin peaks, centered at 1667 to Meest, evenly spaced in harmonic intervals, almost like a chord. A strange coincidence, the spacing matched the same Fibonacci ratio, embedded in the 1977 WOW signal intensity curve. Coincidence. It had to be. Yet even skeptics whispered the phrase that had returned like a haunting refrain. They use mathematics because it never dies. For the next 6 nights, the world listened. The Greenbank telescope in West Virginia turned its massive ear toward the coordinates. The FAST array in China swept the same sky sector, its vast dish shining pale beneath the stars. Nothing, only the one burst. 12 minutes of order in a sea of chaos. Meanwhile, 3SI Atlas continued to drift outward, slower, colder, its light curve flattening into an almost perfect rhythm, as though the object had stabilized. The old tumbling signature from September, the uneven flicker, was gone. Now it rotated with machine regularity, each spin lasting exactly 42 seconds, the same number as the radio pulse interval. The coincidence was so mathematically exact that one physicist at Caltech simply muttered, "It's talking with its body." Night after night, observatories stayed awake, catching faint photons and listening to a silence charged with meaning. The work was slow, repetitive, meditative, but it felt sacred. In Chile, technicians bundled in thick jackets against the desert cold stood outside the dome between exposures, staring at the horizon where the object glimmered like a dull ember above the mountains. The air smelled of dust and frost. The stars were knife-sharp. Somewhere far beyond a relic older than time, turned once every 42 seconds, perfectly indifferent, perfectly constant. Inside the domes, machines hummed. Computers, whispered data streamed through glass fibers like veins of light. Across half the world, human beings shared the same impossible task, listening for something that might never speak again. And yet every antenna, every mirror, every trembling hand on a keyboard said the same silent thing. "We heard you once. We're still listening." The trajectory, refinements. By the middle of December 2025, the numbers were finally in. Orbital fits from Chile, Hawaii and the Deep Space Network converged into a single elegant curve. After weeks of suspense, the verdict was both anticlimactic and astonishing. In its precision, 3SI Atlas was moving on a purely gravitational path. No thrust, no measurable acceleration, no drag, no trace of residual outgassing or solar cell behavior. The data agreed down to the 5th decimal place. For the first time since its discovery, every model from NASA's JPL Horizons to ESA's Propagation Archive drew the same trajectory and unbroken hyperbola as if written with a ruler across the fabric of space-time. To the relief of the agencies, it meant one thing: nature still held the pen. Or so it seemed. At the European Southern Observatory, a small press briefing was held on December 17th. The mood was careful, measured. Dr. Lucia Moretti, the lead orbital analyst, stepped to the podium and read the statement twice, Almost as if afraid to breathe between the lines, we have found no evidence of non-gravitational forces acting on 3I Atlas. Its motion is consistent with Newtonian and relativistic mechanics. Within the limits of measurement, it behaves as an inert body under solar influence. Applause followed polite uncertain like a sigh more than celebration. The anomaly for the moment was over. But what came next was stranger still. That same afternoon, Avi Loeb of Harvard released a preprint titled Symmetry as a Signature. The paper was brief, only 6 pages, but its premise hit like a quiet thunderclap. If randomness is the default state of nature, he wrote, then perfect symmetry is not evidence of orderlessness, but of design. Loeb pointed out that most interstellar objects, comets, asteroids, even dust clouds exhibit imperfections, tiny deviations, chaotic tumbling, subtle variations in reflectivity. Their orbits drift under solar radiation, gravitational tides, or molecular outgassing. None move in absolute balance. But 3I Atlas did. Not only was its motion purely gravitational, it was perfectly symmetrical about the solar plane. Such exactitude, he argued, might not indicate natural simplicity, but active calibration, a system designed to self-correct, without propulsion, like a perfectly weighted gyroscope. The absence of thrust, Loeb wrote, does not prove the absence of control. It may prove the elegance of it. The scientific world divided overnight. On one side stood the conservatists. Orbital mechanics is deterministic, not theological. Perfect symmetry can happen, rare but not impossible, the result of an old inert fragment settling into balance by chance. On the other side were those who saw Loeb's argument as poetic but dangerous an invitation to re-enchant the data with human longing, and yet his logic lingered persistent as gravity. If chaos is the rule, then order itself becomes the anomaly. In Cambridge, graduate students spent nights comparing 3I Atlas's parameters to those of known human-made spacecraft. The parallels were unnerving. A perfectly gravitational trajectory is precisely what engineers attempt to achieve when sending probes into deep space using gravity assists and precise mass distribution to ensure zero fuel consumption. The less a spacecraft fights the universe, the longer it lasts. In the words of one NASA engineer, we call it passive stabilization. The best spacecraft is one the universe itself wants to carry. Viewed that way, 3I Atlas wasn't an unpowered relic, it was a masterclass in efficiency. Its stability wasn't evidence of randomness, it was evidence of understanding. Because to design something that could drift for billions of years without tumbling, fragmenting, or deviating, you would need to know the cosmos intimately, its tides, its frictionless winds, its subtle harmonies. You would need to build not against the universe, but with it. Avi Loeb's critics dismissed the notion as romantic speculation, but others quietly echoed it. Astrodynamicist Dr. Helena Ruiz, the same researcher who had earlier modelled Mars's electrostatic deposition, said in an interview, "It's the difference between a leaf and a sail. Both move with the wind, but only one is shaped to use it." Perhaps 3I Atlas was that shape, a design so ancient, so refined, that it no longer needed engines or instructions. A machine that had become indistinguishable from motion itself. By December 20th, the media had latched onto the phrase designed balance. To some it sounded spiritual, to others mathematical. But everyone understood what it implied, that perfection might be its own fingerprint. If nature tends toward a symmetry, then 3I Atlas was an outlier. And if perfection cannot be coincidence, then perhaps coincidence is how perfection hides. That week, as the last orbital data came in, scientists turned their telescopes one final time. The object was moving steadily away, now past the orbit of Mars, its light curve shrinking to a pinpoint. From Earth, it was little more than a dim pixel lost among millions. But within that pixel, all the arguments of science and philosophy converged: randomness, or reason, chaos, or craftsmanship. And perhaps the answer was both. Because even if 3I Atlas was only a rock, a relic of the first stars, its balance carried meaning. It showed that the universe itself could sculpt elegance out of entropy, that motion could resemble intention, that stillness could hide intelligence. In spacecraft engineering, there's a saying, if it flies true, don't touch it. So maybe that's what 3I Atlas was, a traveller that had been flying true for 14 billion years, and a universe wise enough not to touch it. The Mars surface mystery deepens. December 18th, 2025. While Earth's observatories argued over orbits and radio pulses, another kind of story was unfolding 225 million kilometers away. The ESA Trace Gas Orbiter had just completed a new imaging sequence of Noctis Labyrinthus, the same canyon region that 2 months earlier had revealed those faint metallic lines glimmering at dawn. This time the lines were still there, only now they had multiplied. At first the analysts thought it was a calibration artifact misalignment pixel drift, or maybe a scattering quirk from the low Martian sun. But when the images were layered over the October datasets, something undeniable emerged. The bright streaks had expanded. In several valleys the reflective bands had doubled in length, running parallel to one another like veins of quicksilver across the red terrain. Their geometry remained eerily consistent, straight-measured, converging toward canyon junctions like tributaries of light. They weren't random frost patches, they were patterns. In Darmstadt, at the European Space Operations Centre, the room went very quiet. The scientists had seen anomalies before, the tricks of light that Mars loves to play, but this was something else. The lines obeyed topography too neatly. Where a ridge curved, they curved. Where a basin deepened, they faded and reappeared on the other side. For 3 days the imagery passed through verification cycles, photometric correction, multi-angle simulation, atmospheric modelling. Nothing erased the geometry. That's when the public leak began. A high-resolution composite found its way to the internet, and within hours the old debate reignited under new banners. Martian patterns. Terraforming. Now, the Atlas effect. Millions of people saw in those silver lines whatever they wanted to see: runways, architecture, writing proof. But science is slower than wonder. And into the storm of speculation stepped Dr. Stuart Johnson, head of ESA's Planetary Geology Division, a man known for his patience and his dislike of adjectives. At a hastily called press conference in Paris, he stood before the projected images and said simply, "We do not yet know what we are looking at." He explained that Mars' atmosphere, thin as it is, can produce complex deposition effects. Nickel-rich dust, electrostatic adhesion, and seasonal CO2 frost can mimic structure under changing light. The growth seen in the new images might not be expansion, it might be illumination differences or angle-dependent reflection. In other words, don't trust your eyes. But the internet no longer trusts caution. Within hours, the press conference clips were sliced into memes. Johnson's calm statement, "We do not yet know what we are looking at," became both a confession and a prophecy. Some took it as evidence of hidden knowledge. Others mocked it as the eternal refrain of institutions caught off guard by the extraordinary. Even fellow scientists felt the tension. The ESA data was clear enough to excite, vague enough to doubt, and in that uncertainty imagination bloomed like mould. Across forums the narrative machinery of myth roared to life. Some claimed the patterns were messages, perhaps the Martian equivalent of Nazca-line signals for whoever sent through our atlas. Others said the nickel dust was replicating self-organizing, forming crystalline filaments that grew in fractal sequence. A viral video from a YouTuber with 1 million followers claimed the lines mapped exactly onto Fibonacci spirals when overlaid on a Mars topographic grid. The comment sections filled with certainty. Every pixel became scripture. Dr. Johnson watched the storm from his office, the blinds half-drawn, the monitor awash in red. He later told a colleague, "We live in a world that loves mystery more than accuracy." He wasn't condemning anyone, just stating a truth of his time. Because science, for all its rigor, has one great weakness: it speaks in probabilities, not poetry. And the human mind craves poetry. It wants stories where cause and meaning are twins, where every pattern is intentional, every silence is message, every anomaly is revelation. The ESA's official report, released December 22nd, tried to set boundaries. Preliminary analysis suggests dynamic dust deposition, modulated by electrostatic and thermal gradients. No biological or artificial process implied. But that sentence landed like a whisper in a stadium full of thunder. The report closed with a single line meant to calm, but instead it lingered like a challenge. Further monitoring will continue. The world read that as keep watching. And in truth, no one could stop. From backyard telescopes to classroom screens, millions of people watched Mars each night, not because they expected movement, but because something inside them needed meaning. When the universe brushes close, the human heart begins to write stories. It's what we've always done. We see shapes in clouds, faces on planets, gods in thunder. We call it myth-making, but perhaps it's something older than belief, a survival reflex of consciousness itself, trying to fit infinity into the size of a thought. Science can measure dust and angles, but myth gives them gravity. In the end, the patterns on Mars may prove nothing more than wind and metal and light. But for a brief moment they reflected us our hunger to connect, to understand, to matter in a universe that rarely speaks back. Dr. Johnson, weary from interviews, wrote one quiet note in his field journal before the holidays: "Mars is not the mystery. We are." And perhaps he was right. Because in the long silence between data and certainty, it wasn't Mars that changed. It was us filling the void with stories turning science into myth, and myth into the shape of hope. The psychology of uncertainty. By the end of December 2025, the data streams had slowed, but the unease had not. The object had faded again, Mars had grown still, and yet the question, the one that could not be answered, hung over everything like a soft, invisible weight. It was then that Dr. Catherine Denning, a cultural anthropologist from York University, published an essay that quietly reshaped how many people saw the entire affair. Its title was simple: Living with Cosmic Ambiguity. Her argument was not about astronomy at all, but about us. Denning began with a sentence that felt like it had been written for this moment. The human mind was not built for uncertainty. It was built for story. From the earliest myths she wrote, we have filled the sky with meaning. When comets appeared, we called them omens. When eclipses darkened the day, we imagined gods in combat. And now, in an age of data and telescopes, we tell the same stories with new vocabulary, alien artifact probe, but the impulse is unchanged. Ambiguity is unbearable because it holds up a mirror to our smallness. We crave closure not out of arrogance but out of fear. She described 3i Atlas as a kind of psychological experiment not conducted by scientists but by the universe itself. It had offered us no answers, only patterns and silence. And into that silence humanity had poured itself science, speculation, belief, and longing. It was, she wrote, a mirror made of motion. What it reflected was not extraterrestrial intelligence, but human fragility. We are creatures who mistake uncertainty for danger. We want the cosmos to be explainable or at least consistent. But the universe, vast and indifferent, asks us to sit with questions that may never resolve. Denning's essay drifted like a slow breath through scientific circles, philosophy forums, even sleep podcasts. It offered a language for a feeling everyone had been struggling to name, that uneasy balance between awe and anxiety. Ambiguity, she wrote, is not ignorance. It is the space where truth matures. To her, uncertainty was not an enemy of knowledge, but its cradle. To live with it was to live awake. She compared our species to early navigators who crossed oceans without maps, guided only by stars that flickered and sometimes disappeared behind clouds. They did not curse the clouds. They learned patience. They understood that discovery was not a destination but a rhythm, a heartbeat between glimpses of light. From that perspective, 3i Atlas was less a revelation and more a meditation. It reminded us that even now, with quantum sensors and orbital arrays, we are still explorers in the dark, listening for echoes, finding meaning in fragments. Science thrives on evidence, but life unfolds in the spaces between it. The art Denning suggested is to remain gentle in the presence of the unknown. There is wisdom, she wrote, in not knowing. Wonder is a form of faith that asks for nothing in return. Her closing lines became a kind of mantra among the Science for Sleep audience, a quiet antidote to panic and speculation. The universe does not owe us certainty. It offers us participation instead. We are not here to solve it, only to listen long enough for it to change us. And perhaps that is the lesson 3i Atlas left behind. Not proof, not revelation, but an invitation to rest within mystery without demanding its collapse into fact. Because sometimes understanding is not a flash of insight, it's a slow acceptance that we may never know what passed through our sky, and that not knowing is its own kind of peace. As the year faded and the observatories grew quiet, the last of the data files closed with a sound like the turning of a page. Above us the stars burned on silent patient, asking nothing, promising nothing, but still so beautifully there. The final approach to Earth. By December's final weeks, 3 Atlas had crossed the invisible threshold that separated abstraction from presence. It was no longer a dot on a projection or a pulse in a radio spectrogram. It was there, a moving point against the winter constellations sliding quietly between the stars. Between December 19th and 31st, 2025, the traveller made its closest approach to Earth, a mere 0.32 astronomical units, away close enough that backyard astronomers could trace its motion night to night, yet far enough to feel impossibly distant, Every major observatory on Earth turned its gaze toward it. From Hawaii to the Canary Islands, from Chile to South Africa, telescopes synchronized like a choir rehearsing the same note. The verdict was unanimous. 3i Atlas followed a perfectly gravitational trajectory. No thrust, no sail effect, no decay. Just smooth, unbroken motion through the sun's invisible geometry. It was, as one researcher described it, the cleanest orbit ever recorded for an interstellar body. The universe itself seemed to be carrying it, not pushing, not resisting, just letting it move. But for every scientist who took comfort in that symmetry, another felt unease. Among them was John Flannery, an Irish astronomer and lifelong stargazer, known for his poetic sensibility as much as his technical skill. He was the kind of observer who still took notes by hand, the kind who lingered after dawn to watch the colour drain from the sky. In an interview on December 27th, Flannery offered a thought that would echo long after the event. We're assuming what we see now is all there ever was. But what if the story began long before we looked up? He pointed out that by the time 3i Atlas was first detected in July, it had already been within the orbit of Jupiter for months, invisible against the glare of the sun. If any maneuvers, adjustments, or interactions had occurred, then they would have gone unrecorded. The object's later perfection might not be natural serenity. It might be aftermath. The idea unsettled and fascinated in equal measure. Could a course correction have taken place before discovery, a brief burn or release timed with exquisite precision, leaving behind nothing but balanced motion? Theoretically, yes. A single maneuver at high solar proximity could have aligned its current path flawlessly, with gravitational vectors making all later movement appear inert. An act of design hidden inside the illusion of simplicity. Flannery called it the vanishing act of physics. If you know enough about gravity, he said, you don't need engines, you just need timing. NASA analysts declined to speculate, but privately admitted that the early data gap from May to July 2025 would forever remain a blind spot. By the time Atlas in Chile first caught the object, it was already outbound, slowing into its long glide past Mars and Earth. Whatever had happened before that, whether nothing or everything, was gone, erased by sunlight and distance. The result was a strange kind of calm. Science had all the answers it could, and none that it wanted. The orbit was perfect. Too perfect. On December 30th, 3i Atlas made its closest sweep across the plane of Earth's orbit. Amateurs from Tokyo, Oslo, and rural Kansas posted their captures online, streaks of faint silver light against the velvet dark, a blur between Orion and the dim arc of Gemini. It looked peaceful, ordinary, forgettable. And yet every image carried the same quiet electricity, the knowledge that something older than time itself was passing close enough for human eyes to notice. At the European Southern Observatory, the last official tracking report concluded, no detectable thrust signatures, no mass shedding, no anomalies beyond expected gravitational precision. Object is outbound and stable. Predicted solar escape trajectory confirmed. That was it. The data ended with that line. No mystery, no revelation, only the silence of completion. But among the footnotes, one final sentence stood out, italicized by Flannery in his own field log later that night. The absence of evidence, he wrote, is not evidence of absence. It is only the point where our light stops reaching. For Science for Sleep listeners, the moment had the rhythm of a closing breath, a story coming full circle, not with revelation, but with restraint. Because sometimes the greatest mystery is not what we find, but what passes quietly beyond our ability to see. On New Year's Eve, as fireworks echoed faintly through the cold air of Earth's cities, the Atlas slipped unnoticed beyond the orbit of Mars, a speck of motion vanishing into the dark. No message, no signal. Only that perfect silent curve, a reminder that the universe may never explain itself, but it never stops inviting us to look. The communication failure. In the first weeks of 2026, the dust of discovery began to settle, but what lingered wasn't understanding. It was confusion. The telescopes had done their work. The data was archived, the coordinates verified, the equations balanced. 3 Atlas was gone outbound into the dark again. Yet what remained on Earth was not calm, but fracture, a widening gulf between those who measured and those who imagined. It wasn't the first time humanity had watched a mystery slip through its fingers, but it was perhaps the clearest example of how science and story, our two oldest ways of knowing, can collide instead of cooperate. The failure wasn't in the instruments. It was in the conversation. When scientists said we don't know the public heard, we're hiding something. When researchers said ambiguous data, the internet translated it as classified evidence. The lexicon of caution built over centuries to protect truth from haste became in this moment the language of mistrust. The irony was painful. The more carefully scientists tried to speak, the more conspiratorial they sounded. It wasn't the first time this had happened. In 1947, when the US Air Force fumbled its public explanation of a downed weather balloon near Roswell, they set fire to a myth that still burns today. In 1996, NASA's announcement of possible microbial fossils in the Martian meteorite ALH-80 4001, that tiny ancient rock from Antarctica, ignited global euphoria, then disappointment, then cynicism. Both events followed the same Ark Wonder Proclamation retraction backlash, and each left a scar on the fragile relationship between science and the human imagination. People don't remember uncertainty, they remember betrayal. The 3 Atlas episode followed that same rhythm in miniature. When agencies fell silent during the government shutdown, suspicion filled the void. When they returned with careful statements, purely gravitational motion, no evidence of artificial influence, the public heard only denial. To a population conditioned by decades of mixed messages that caution sounded like control. But the truth is quieter and lonelier. Most scientists weren't hiding secrets. They were hiding doubt. Science at its heart is humility formalized in admission that knowledge must be earned molecule by molecule, photon by photon. But humility does not translate well into a world built on instant certainty. In a society tuned to hashtags and headlines, nuance feels like weakness. A pause between answers feels like guilt. And so the scientist's silence became the story again. Dr. Stuart Johnson, weary from interviews about the Martian patterns, wrote an editorial in Nature Astronomy titled The Weight of Caution. In it, he described the emotional toll of the public's disbelief, not because people asked too many questions, but because they stopped believing that questions could be honest. We have mistaken confidence for truth, he wrote. The hardest thing a scientist can say is, "We're not sure yet." The hardest thing the public can do is to accept it. His words echoed through universities and classrooms where teachers tried to reframe the story for their students not as failure, but as reflection. That sometimes communication is not about what is said, but how much silence it must carry. Anthropologists began calling it the communication crisis of 2025. They noted how every generation replays the same drama, a revelation at the edge of comprehension, followed by argument over who gets to explain it. The pattern stretches from Galileo's telescope to Oppenheimer's bomb to the Hubble Deep Field. Each moment began with awe and ended in misunderstanding, not because people were irrational, but because wonder is hard to translate into data without losing its warmth. We're a species fluent in metaphor, not measurement, and when the universe answers in numbers, we scramble to turn them back into meaning. By January 2026, 3I Atlas had become less a topic of science and more a symbol. Conspiracy forums called it the visitor that proved the cover-up. Philosophers called it the mirror that proved our impatience. And between those extremes, quiet voices tried to build bridges. Educators, astronomers, and communicators began holding evenings of ambiguity public sessions, where people could ask unanswerable questions under dark skies. No slides, no certainty, just open conversation, a kind of therapy for curiosity. Perhaps that was what was needed all along. Not control, not revelation, but trust. Trust that not knowing isn't ignorance, that doubt is not deceit, that a pause in the story is sometimes where understanding grows, because the failure of communication is never just about information. It's about fear, the fear that the universe might be larger, stranger, and less explainable than we hoped. But humility, if we let it, can be its own kind of light. It reminds us that even the most advanced science is still a form of listening, and that listening requires silence, patience, and faith, that meaning will come in its own time. For the Science for Sleep audience, the lesson rests gently between science and philosophy. We cannot demand the cosmos speak in human terms. We can only learn to listen in it. And perhaps that is how progress truly happens, not when we find all the answers, but when we finally make peace with the language of uncertainty. The Departure and the Meaning of Mystery, January 2026. The new year dawned, clear and cold, and the object that had once ignited a planet's curiosity was now little more than a faint whisper of light in the dark. 3 Atlas had slipped beyond Mars's orbit, its speed steady, its brightness fading, its course immutable. By mid-month, even the largest telescopes could barely detect it. The final data point from the Vera Rubin Observatory showed a magnitude so low it was almost noise, a single photon every few minutes too faint for the eye, too persistent to ignore. After that it was gone. The traveller had left us behind. At Harvard, Avi Loeb published his closing essay, not a paper but a reflection. Its title read simply, "The Visitor That Taught Us to Wonder Again." Whether natural or artificial, he wrote, 3i Atlas reminded us that discovery is not a possession, but a relationship. It asked us to look to question and to feel humility before what will not explain itself. He compared it to Galileo's first glimpse of Jupiter's moons, a moment when the familiar sky quietly grew larger. We hadn't proven intelligence in the stars, Loeb admitted, but we had rediscovered something just as vital, the capacity to be astonished. In the weeks that followed, astronomers slowly turned their instruments away. New missions reclaimed the headlines, exoplanet atmospheres, gravitational lensing fusion breakthroughs. But for those who had spent sleepless months tracking the traveller, something had shifted. They spoke of an odd emptiness in the data stream, a silence where once there had been nightly motion. A small loss, barely measurable, yet it carried the same melancholy as watching a ship vanish beyond the horizon. One technician in Chile described it best. It's strange. The stars look the same, but they don't feel the same anymore. For Science for Sleep listeners, this was where the story softened into reflection. Because 3i Atlas was never only about the stars. It was about the mirror they hold up to us, to our restlessness, our yearning, our endless drive to understand what may not wish to be understood. We watched an ancient traveller pass through our neighbourhood, and in its silence we heard our own. We saw that science, for all its equations, still begins with something tender, a kind of reverence. The willingness to look at the unknown and not turn away. In Dublin, John Flannery kept his telescope aimed toward the coordinates for several nights after the last detection, even when he knew there would be nothing to see. He said it helped him sleep like leaving a light on for someone who's gone. He wrote in his journal, "Perhaps mystery is not a gap in knowledge, but the shape of our attention. The unknown keeps us listening." Those words spread quietly online, finding their way into classroom posters, podcasts and sleep stories. They became a mantra for those who had followed the saga, a small luminous consolation. By spring, 3i Atlas had crossed Jupiter's orbit and was heading outward on its eternal parabola. Within a year it would slip into the heliopause and then into the deep between stars, joining the invisible drift of ancient matter it came from. No one would see it again, but perhaps that was the point. We were never meant to keep it, only to notice it. If it was natural, it taught us how alive randomness can seem. If it was artificial, it taught us how elegant nature can be. And if it was both some synthesis beyond our categories, it taught us that the universe does not need to choose between miracle and mechanism. In the end, the difference hardly mattered. What mattered was what it left behind, a renewed capacity for awe. The cosmos has no obligation to resolve its mysteries. It only asks that we stay awake to them, to the faint shimmer of movement at the edge of knowledge, to the humility of scale, to the astonishing fact that for one brief orbit of time, consciousness looked outward and found itself reflected in the cold mirror of the stars. And so the traveller continued on, silent, patient, unburdened by explanation. And we left, spinning on our blue world, turned our eyes upward once more, not in fear nor certainty, but in gratitude. Because perhaps that is the universe's quietest truth, that mystery is not there to frighten us, but to keep us awake to wonder.